Alright, let's take one more look at timeline items module and see how here we update timeline item objects. So here we have set timeline item activity which updates activity ID property, as well as update timeline item activity seconds for updating activity seconds property. But why don't we try to combine these two functions into one and create generic function to update any property of timeline item object? So let's do just that. We're gonna call new function update timeline item, which is going to accept two params. First one will be timeline item object that we are about to update, and the second param will be object with fields, which is going to contain new values for properties. And then in here we're simply going to override properties contained inside fields object and assign new values of those properties to properties contained inside timeline item object by using function assign. And in the end, method assign is going to return object with overridden properties. And now we can try to use this function, so for now let's just go ahead and comment out these two functions, and then let's find out where setTimelineItemActivity function is used. Let's go into this component, and in here we're going to replace this call on our new function updateTimelineItem. But of course we have to tweak params a little bit, because as you can see in here, setTimelineItemActivity function was accepting two params, second of which was primitive value activity ID, but in our case updateTimelineItem as a second param accepts object of properties. So we're gonna have to directly specify which property we are overriding, and in this case we are overriding property called activity ID. So let's pass an object with only one property, activity ID, and the new value stored inside event variable called $event, like this. And the only other thing we also have to do in this component is actually replace setTimelineItemActivityImport on updateTimelineItem function, like so. And now we are ready to check it out in the browser. But before doing that, let's actually take another look at function updateTimelineItem. So in here we're accepting two params. First one is the actual timeline item object we're about to update, and the second param is an object which contains new values of properties we're about to override in the first object. And as a reminder, every timeline item object consists of three properties. And those are our activity ID as well as activity seconds. So in that particular case, inside of timeline item object, when we were calling updateTimelineItem function and passing object with only one property, activity ID, as the second argument, this way we are overriding only one property called activity ID of timeline item object. And now let's actually go ahead and do the same replacement for the second function before checking everything in the browser. The second function is updateTimelineItemActivitySeconds. So let's see where this function is currently being used. Go into this component. And the first thing we're gonna do in here is actually replace an import of this function on our new function updateTimelineItem. And whenever we were using that function, let's replace all those calls on updateTimelineItem function. So we're gonna follow the same steps and replace function name on function updateTimelineItem, and as a second parameter we're going to convert this argument on object with only one property that we are updating in this case, and that is activity seconds property. And of course this replacement should be made in every place where that function is used. So let's do this for the second call of this function. Along with that, we're also going to change second parameter on object, just like we have done in the first case. And finally, there is also one more entry of that function that we are calling inside the reset function. This entry we're also going to replace on updateTimelineItem, and the second argument will convert into an object with one property, activity seconds, like so. And after doing all these modifications, we are actually ready to check it out in the browser. So let's just see if we can still select activity for timeline item object and start tracking time for this activity. And we also make sure that this time will be decreasing on activities page. So this functionality is working. And also let's try to remove activity and make sure no errors happen during removal. This part is working as well. Let's go back to the editor. And now that we have completely replaced all mentions of these two functions across our codebase, we're now ready to completely remove these two functions. Let's do this. let's remove this commented code. And now we're gonna work on a refactoring of reset timeline item activities function. So if we take a closer look at this function, here we can see that by iterating over timeline items objects, in this closure we're actually doing two different operations. The first operation checks condition, and the second operation is actually the code that executes only when the condition is met. So we're kinda mixing these two operations into one function, but why don't we try and actually split these two concerns into two different steps. The first step will take care about filtering only necessary items, and the second step is going to do necessary operations on the filtered items. So as the first step of this chain of operations, we're going to call function filter to filter only items that we need. And in here we're basically going to check that condition, and after this filter method executes, we no longer need to check that extra condition in the closure of for each method anymore, so we can get rid of that condition and just call method for each on the new array that we have received after executing filter method. And this way we're gonna get such code where inside the second closure, where we're going to basically do simple assignment. And by doing this assignment, we're actually updating timeline item object, but since previously we have already created generic function to update timeline item objects, why don't we reuse that function in this closure? So let's just call that update timeline item function in here, and as a first parameter we're going to pass timeline item object we need to update, and as a second argument we're gonna pass object with fields that we are going to override. So in this case we're overriding two properties at the same time, activity ID as well as activity seconds. Let's convert this notation into valid JavaScript object. And also in here we have to be careful with usage of parentheses. Let's make sure that all parentheses are closed. And now let's see if that function works by trying to select an activity for a timeline item object. Here we're making sure that proper activity ID was assigned to activity ID property of timeline item object. And then if we're basically going to remove this activity on activities page, then we're supposed to get that activity ID property reset and assign value null. And as we can see, it worked. So our refactoring was successful. Let's continue. So we can go even further, and if we take a look at timeline item module once again, we will see that in here we are repeating the same code twice, and that is this filtering function, which uses the same condition. So we can basically move this condition out of these two functions and create new function that is basically going to do this filtering for us. So let's call a new function has activity, which is going to take two params, timeline item object and activity object. And here we're going to check if activity object passed as a second argument into this function is actually assigned to the timeline item object passed as a first argument to this function. So we're going to copy over this condition, paste into our new function, and then we're going to use this function instead in this filter closure. So let's call hasActivity function and pass required parameters, which is timeline item object and activity object, like so. And now we can do pretty much the same thing once again. Let's copy call of this function and paste it into this filter function. And this way we were able to reduce code duplication a little bit and reuse some parts of code. So at the end, let's see if our application still functions properly. Let's choose a time for this activity, and then on timeline page, let's go ahead and start tracking the time for this activity and make sure the time will be decreasing on activities page. This part is working. And if we decide to remove this activity, then on timeline page, this timeline item object is supposed to reset that coding activity. And as we can see, it shows activity rest as a default one, which means activity was reset. So our application is working. We're going to continue development in the next lesson. Just like we created generic function for updating timeline item objects in the previous lesson, in this lesson we're gonna do the same thing but for another resource, activities objects. So currently we only have one function which updates activities objects, and that is setActivitySecondsToComplete, which is called in here. Let's take a look at the definition of this function. And since this function manages activities resource, it is defined inside activities module. So in this module, besides this function, we also see functions responsible for creating new activities as well as deleting activities. So we're gonna create the function with a name updateActivity, which is of course going to accept activity object we're about to update, and another object with overridden properties. Let's call this object fields, just like we have done with updateTimelineItem function. By the way, we can just copy over implementation of this function and paste this line into our function updateActivities. The logic will be pretty much the same. We just have to rename the first parameter we're passing in here onActivity. And that's all what's required to update activity object. And now let's go back to that component where we are using setActivitySecondsToComplete function and replace this function called onActivated function. But of course, along with this, we also have to tweak second parameter a bit, because now it accepts an object with properties we are about to override. And in this particular case, we are overriding property called seconds-to-complete. So let's specify this property in the form of an object like this. But that's not all, because if we take a look at the implementation of setActivitySecondsToComplete function, here we can see that we are also using fallback to 0 in the case when second-to-complete property will be falsy. So we also have to maintain this behavior with our new function updateActivity. So let's just move this fallback part and actually paste it in here where we are constructing new object of overridden fields like this. And in case event variable will be falsy, we're gonna fallback to 0, and 0 will be assigned to seconds-to-complete property of activity object. And at this point, the only thing left to do is actually replace setActivitySecondsToComplete function on updateActivity like this. And in the browser, let's see if our new function actually works. Let's watch seconds-to-complete property of activity object. And when I try to set up the time for this activity, and we're supposed to see that that property will actually get updated with a new selected time. And indeed, it is working. Every time we're gonna select new time, this property will receive new time in seconds. So let's just go back to the editor one more time and finally remove that old unused function setActivitySecondsToComplete from activities module. And on this, we're finishing this lesson. Link to the source code of this project will be in the video description. Let's consider one more time how we are implementing the behavior to scroll the page to a particular timeline item when clicking on these our labels. And in order to implement that scrolling, we also had to assign a reference to the timeline component right here. And then we use this reference anytime we switch over to timeline page inside the navigate function. If this first conditional block executes, that means that we have clicked on the logo. And we're using that timeline ref in order to scroll the page to current timeline item. And the reason why we had to register that ref is that because the function that is responsible for scrolling the page to a particular timeline item is actually declared inside the timeline component right here. So we're using that ref to get access to this function to be able to call it outside of this component. But now we're going to change this behavior a little bit. So now we no longer have to assign this reference. We can get rid of this reference as well as of its import right here. And since this reference isn't going to be used anywhere else, we can go to router.js module and remove its declaration. So let's remove this line. But now we're no longer able to call the function scroll to hour in this place, because we don't have a reference to the timeline component. And in addition to that, this function navigate seems to be doing a lot of things. But in fact, it should only be responsible for one thing, which is navigating between pages. And now we're going to apply refactoring to this function. So it will only be responsible for switching between pages and also making sure that anytime we switch the page, scroll bar will always be located at the top of the page. And that's what this scroll into view method is responsible for. And that's actually all what this function is going to be doing. But after doing all these changes, we of course have to go to different places and appropriately refactor the code. So for example, let's go inside the logo component first. And here, when clicking on the logo, we execute that function navigate, but now it will not be enough, so we're gonna declare another local function inside this component, handle click. And in here, we're gonna paste that code that we just cut from navigate function and write the following ternary condition in this function. So first of all, when clicking on the logo, we have to check which page we're currently on. And if we're currently on page called timeline, that means we're not gonna have to do any navigation, but instead only scroll the page to a particular timeline item, specifically to current timeline item, and to do so, we can call that function scroll to hour with no arguments. Otherwise, if we are being on another page, then while clicking on the logo, we of course have to navigate to the page timeline, which we can do by executing navigate function and specifying correct page name that we'd like to navigate to, like so. But here we also have the same problem because function scroll to hour is not available to us, because we previously removed that timeline ref. So what we have to do now is actually somehow make this function available for other components and modules to use. But before doing that, let's go back to the logo component and remove this commented code. So now let's register this function handle click as an event handler for this link, and then import current page variable from router module. And what we're going to do next is actually make scroll to hour function available to be used in this component. So right away, let's just import this function from timeline items module. This is the module we're about to move that function. So let's just go ahead and cut this function from the timeline component, switch over to timeline items module, and right here, we're going to paste that function and export it like this. And there is also this array of refs called timeline item refs, which we are referring in here. So we have to move declaration of this array also to timeline items module. So let's cut this declaration from the timeline component and paste it inside timeline items. Since this array of refs directly relates to timeline item resource, and this will be an appropriate place for this array to be declared in. Let's not forget and export this array as well. And let's see what else should be imported inside this component. We're also using in here function current hour, so let's scroll up and add an import statement for this function. We're importing this function from the functions module. And one more thing that we also have to add an import for is this midnight hour constant. One more time, let's scroll up and add this constant right here. And now all this data, timeline item refs array as well as scroll to hour function, we should import inside the timeline component. So let's switch over to this component and add necessary imports. And the rest of the imports that are no longer used in this component can safely be removed. And now that we have access to scroll to hour function, which we can by the way import directly from timeline items module, we no longer need to use this define expose macro in this component to provide access to scroll to hour function to parent component. So we're going to remove this macro. And now if we'll check the result in the browser, we will see that while clicking on our labels, the page is still scrolled to particular timeline items. So our previous behavior is working fine. So when clicking on those hour labels, we're executing this event handler, which is scroll to hour function that we have previously imported directly from timeline items module inside this component. And also while clicking on the logo, the page will be scrolled to current timeline item, as we can see. So one more time, let's check how all this is working, starting from the logo component. So when we click on the logo, we're going to execute handle click function, which is going to check if we're currently being on the timeline page. Then we don't need to navigate anywhere, but instead we just have to scroll the page to current timeline item, which we're doing by executing scroll to hour function in here. And just because we have previously moved declaration of this function inside timeline items module, we can easily gain access to this function by importing it directly within any component we need. And now let's consider another case. That is, when we are navigating to a timeline page, we have to be also automatically scrolled to current timeline item, but the scrolling in this case should be instant. And when we have this scenario, the other part of this condition executes, and we're calling function navigate in order to navigate to a different page. And if we take a look one more time at the declaration of navigate function, we can see that this function now contains only 2 lines, whereas previously it contained many more. So right now this function is only responsible for navigating to a different page, as well as ensuring that the scroll bar will be always on top of the page. And let's just go to the root component and take a look at the template. As we can see, this template currently looks pretty clean. But even this template has some room for improvement. So we're going to work on improving this template in upcoming lessons. And for now, let's go over several pages in our application and make sure we don't face any errors and everything is still working as expected. So as we can see, there are no errors. We can continue in the next lesson. Even though we have simplified the scrolling behavior to a particular timeline item in a previous lesson, we still have only one function which is responsible for scrolling the page to a particular timeline item as well as to current timeline item. But it will be good to split these two concerns and create separate functions for each case. Let's consider the first scenario where we have to scroll the page to a current timeline item. And this happens inside the logo component. When we click on the logo, we're going to execute function scroll to hour to scroll the page to current timeline item. And another scenario where we have to scroll the page to current timeline item is that whenever we are navigating to timeline page from a different page, and the code for it we have inside of the timeline component, inside the closure of watch post effect function. So here we're checking the value of the reactive variable current page, and if this variable will be equal to page timeline constant, in other words, when we're gonna navigate to the timeline page, we're going to execute these instructions and scroll the page to a particular timeline item. But as we can see in both these cases, we're still using one function scroll to hour, which is responsible to scroll the page to a particular timeline item, but not the current one. And although all this works, I prefer to simplify this code and make it more explicit by creating a separate function which will be responsible to scroll the page only to current timeline item. So let's go inside the timeline items module, and in here let's declare a new function called scroll to current timeline hour. And the only parameter this function is going to take will be isSmooth with a default value of true. And here we just have to delegate the behavior to scroll to hour function with the predefined parameters that will make scroll to hour function to scroll the page to current timeline item. And to do that, we have to pass current hour as the first parameter. And by the way, current hour can be retrieved by using current hour function call. And as for the second parameter, we're just going to pass isSmooth parameter further down to scroll to hour function like this. And now there is actually no need to specify default value for the parameter hour inside the scroll to hour function, so we can remove this default value, and since our parameter will always be passed from outside, we don't need to additionally assign current hour to the hour parameter, so this line is no longer necessary. Let's remove it. And now we have two separate functions that are responsible for concrete cases. The first case will be to scroll the page to the current timeline item, and the second case will be to scroll the page to a particular timeline item. So now, anytime we have to scroll the page to a current timeline hour, we're going to replace scroll to hour function call on scroll to current timeline hour. The first scenario will be inside the logo component, so in here we're going to replace this call on scroll to current hour function. And of course, let's also replace this import on scroll to current hour function. And the other scenario where we can call scroll to current hour function is inside the timeline component. So in here, we'll replace scroll to hour on scroll to current hour, and this function accepts only one parameter, so we can remove first parameter null. So let's just go ahead and import this function inside this component and check final result in the browser. So while clicking on our labels, we can see that the page gets scrolled to a particular timeline hour, as well as it gets scrolled to current timeline hour when clicking on the logo while being on the timeline page. And there is one more case that we still have to check, and that is navigating to timeline component and making sure that we will be scrolled to current timeline item. As you can see, this behavior is also working. So our refactoring was successful. The link to the repository of this project will be in the video description. Now we finally get to the point where we can refactor our routing. So currently, for the routing, we're using v4 directive to determine which page should be displayed at the current moment. But as you can see currently, in Vue Developer Tools, all our page components are contained in the DOM, and that is the timeline, the activities, and the progress components. And if we go to the root component here in the template, we can see that we are determining which component to display based on the value of the current page. And by using vShow directive, and as we know, vShow directive is not going to remove component completely from the DOM tree. It will just hide component with CSS in a case when condition inside vShow directive will turn to false. And this is actually a good use case to use dynamic component. Whenever in a project we're having such case when we're checking the value of some variable, and based on the result, we should display certain component. In this case, it will be a good fit to use dynamic component. And one dynamic component is already used in our project, that is to display icons for navigation links inside navItem component. So in here we are determining which dynamic component to display based on the icon property of navItem object. So let's just use the same technique and apply dynamic component for our routing inside app component. Let's write in here component and use isAttribute. And now we need to decide what we're gonna put in this attribute. For now I'm going to write code up front, which is not going to work just yet, but we're gonna make it work soon. So let's just decide which page component to display at some point in time based on the current page reactive variable, and we're gonna use value of this reactive variable as a key of routes object, which is going to contain all our pages. So now let's scroll up and add an import statement for the routes object, and now these imports that are dimmed we're going to transfer to router.js module. Let's also copy over these three import statements. And now we get to decide which shape routes object will have. So let's just do this. Every key of this object will correspond to a particular page name. And as for these names, we can use page constants. And as for the value for every key, we're going to use specific page component. So for the first page, we'll use the timeline component. For the activities page, the activities component. And finally, for the last page, the progress component. And now such object structure perfectly fits our condition that we have wrote inside this attribute is. So depending on which page current page variable will store, we're going to extract correct page component out of routes object and use it to display for this dynamic component. And then dynamic component will take care of the rest and properly show certain page component. So let's just remove this commented code and check the whole result in a browser. We're just going to switch between different pages and make sure that we are still able to do so. And looks like everything is working, but there is one thing that doesn't work as expected yet. So let's just do this. I'm going to start stopwatch in here and then switch over to a different page and come back to timeline page. And in this case, as we can see, stopwatch was stopped automatically. So what is actually happening in here is that whenever we switch between page components, every time old page components got destroyed, along with all the components inside those page components. So this means all the descendant components of the page component is going to lose its state along with the page component. And that is actually the reason why stopwatch component loses its state and stops automatically when we come back to timeline page. And please note, now that we are using dynamic component to implement routing, only one page component exists in component tree at a time. So what we have to do in this case, in order to prevent components from losing their state when another dynamic component gets activated whenever we are switching between different pages, is to actually wrap our dynamic component in another component that is also provided by Vue. This component is called keepAlive. So let's just wrap our dynamic component within this component. And now inside Vue Developer Tools, we can see that our page component is wrapped by keepAlive component. And this keepAlive component is going to cache the state of all components that will be replaced by another page component whenever we go to a different page. And anytime we're going to come back to timeline page, which means the timeline component will be activated again. keepAlive component is actually going to restore the state of all descendant components as well as the current page component. And which is why now if we start the stopwatch and then go to the different page and come back to timeline page, we can see that this stopwatch will still be running. So the state of the stopwatch was persisted between page loads. And one of the state variables of timeline stopwatch component is this isRunning variable, which will have a numeric value when our stopwatch is running. And let's just see what is going to happen to this local state variable when we will switch over to different page and then come back to timeline page. So isRunning variable still stores numeric value. That means previous state was cached and now it is restored when timeline page component was activated again. And this is how we can use keepAlive component along with dynamic components to persist, or in other words, cache the state of dynamic components that get deactivated and replaced with another dynamic components. So that next time when those dynamic components will get activated again, their previous state will be restored. Now that we have started using dynamic component to implement our routing, we can actually drastically simplify the logic for scrolling the page to current timeline item when we navigate to the timeline page. And currently, in order to do that, we actually do the following thing. We use watchPostEffect function inside the timeline component. And anytime current page reactive variable changes, this closure runs again. And if we're currently navigating to the timeline page, this condition will turn true. And before actually scrolling the page to current timeline item, we wait until Vue will apply all updates to the DOM, and only after we're calling scrollToCurrentHour function to scroll the page to current timeline item. But now, since we are displaying only one page component at once by using that dynamic component inside the root component, there is another hook that Vue provides us with called onActivated that will perfectly fit our current scenario. So let's just use this hook in here. Let's call onActivated function. This function accepts a closure, and this closure will be executed over and over again whenever we're gonna switch to the timeline page. So whenever our current timeline component will become activated, in other words, when the dynamic component that is currently used inside the root component to implement the routing will display the timeline component, this closure will be executed again, and once we are on the timeline page, we can easily call scrollToHour function to scroll the page to current timeline item, like this. And just to make sure that this closure will be executed, we're also placing here simple console log statement. So now, let's just remove watchPostEffect usage, we no longer need it. And also, let's remove a couple of imports. And of course, we'll also have to import our new function onActivated from the Vue package. And now we are ready to check this behavior in the browser. So when I initially will load a timeline page, right away in the console, we're gonna see that log activated. And this log is only going to appear whenever we're gonna navigate to the timeline page. So once again, let's just go to the timeline page and make sure that we're gonna see another activated log entry. And of course, as you can see, we are instantly scrolled to current timeline item. But if we are going to go back and comment out this call and check it again, then we're gonna see that the page is not scrolled when navigating to timeline page, and the scroll bar stays at the top. So let's just go back and remove that comment, as well as this console log statement. And also what we can do with this expression is simplify it a little bit. We can just pass the reference to that function that onActivated function should execute, and since we only have to execute scrollToCurrentHour function, we can just specify a reference like this. But also we have to specify first parameter, which is false. But in this case, there is no way to do this. So let's see how we can overcome it. And thankfully, this is pretty simple to do. We just have to go back to the implementation of scrollToCurrentHour function and change the default value for the first parameter. Let's use false. And with that, we need to adjust one function call that is inside of logo component. So let's go in here and pass first parameter true. because now as a default value of the first parameter we're using false, so we have to pass here true explicitly. And now back to the timeline component. And in here we can easily remove that commented code, and now we end up with such notation. So as we can see, we were able to drastically simplify implementation of this component. So one more time, let's check this behavior in the browser and make sure that after navigating to the timeline page, our page will always be scrolled to current timeline item. Everything is perfectly working. So we will continue development in the next lesson. Currently in our project we're using quite a few icons, and for icons we're using custom library. And anytime we have to show up some icon, we firstly have to import component from the library and then reference this component in the template. And that means we currently have all those custom imports spread all over our components. But now let's imagine that in the future we're going to decide to replace this library with another one. That means we have to go through all the components we are currently importing custom icon components and modify all those imports. So to avoid doing that, we actually can apply a different approach. So for example, we can create custom base component that will be responsible for rendering all icons in our application. And in this case, when we decide to change icon library, we're gonna have to modify only that one component that we're going to create right now. So as always, I'm going to create base component inside components folder with the name BaseIcon, and in here let's just add basic skeleton for our component with an empty template tag, as well as script tag with a keyword setup. And the first thing what I'm basically going to do in here is actually write an import for all icon components currently used in our application. So I'm just going to mention all these components right here, and then assign aliases to all these imports, just to avoid repeating word icon as a suffix. And now I'm gonna go down here and create new object called icons. And here we're basically going to copy over all those icon names and use these names as key and values for this object. And a bit later it will become clear why I'm creating this object. So for now let's just reference icon aliases as key and values for this object. And here is an interesting part. Now we're gonna start using this object in the template. So this template will render dynamic component. And as an expression for isAttribute, we're gonna write the following. We will basically reference particular icon component inside of icons based on prop name. And this prop name, of course, will come from outside. And anytime we're gonna have to render specific icon, we're gonna use this base component with a prop name where we're gonna specify which icon exactly we have to render. And of course I'm gonna have to declare this prop, so let's use macro define props and declare one prop called name. This property will be required to pass of the type string. And now what we have to do is actually go through all the components where we currently import custom icon components and actually remove all these imports, and instead what we're gonna do is import our new base icon component. And then in the template we're going to use this base icon component with specifying a proper icon name inside the name attribute. In this case, as we can see, we're using trash icon, so we're gonna specify name trash, and then this dynamic component is basically going to extract component based on the key we have specified inside name prop, which corresponds to the trash icon component. And this way, proper icon component will be rendered by our base icon component. So we can easily remove this usage of trash icon, because base icon component will render icon for us. And now let's go to the next component and pretty much repeat the same actions. So inside of base select component, let's import base icon component and remove the import of xmark icon component. And now let's scroll down to the template and use base icon component and specify xmark as a name for this component. Next up is the activity form component. Here we're also going to remove import of custom icon plus icon and instead import base icon component. The same thing we're gonna do inside of template by replacing this usage of icon component on our base icon component with the proper name in this case, which is plus. Next component that we're gonna modify will be the header progress. So let's remove custom icon component and then add import for base icon component. And inside the template, let's replace this icon component on base icon component. And the name in this case will be check circle. In our next component timelines.stopwatch, we're actually using 3 icons. So we're gonna remove import of those 3 icons and instead import only one base icon component. And then inside the template, we're gonna go through all these icons and replace these usages on base icon usage. So for the first case, we have to reference arrow path icon name. Then for the second case, the icon will be pose icon. Let's specify proper name inside this name prop. And finally, for the third icon component, we are going to use play icon. And finally, let's switch over to the browser and see for now if all our icon components are properly shown. So as we can see for now, everything looks good. But that's actually not all, because we also have to go inside nowItem component and replace every icon for every nowItem component. And as we're gonna see inside the nowItem component, we are currently using dynamic component to show icons. So based on the property icon, we're choosing which icon component to display. Firstly, let's see where this icon property comes from. And this is coming from the data structure that is currently defined inside constants module. It is this array of nowItems. And currently in here, every icon property stores reference to the proper icon component. So in our case, this is not going to work anymore. So we have to replace these icon components on simple icon names as strings. So let's just quickly go ahead and do that and replace icon components on basic strings. The first icon is called clock, the second icon is called list bullet, and finally the third icon is called chart bar. So now that we no longer use any custom icon component imports in this module, we can remove this import. And instead, let's go inside nowItem component, and here we're gonna use our base icon component. So let's add a proper import statement for this component. And then inside the template, we're gonna replace usage of the dynamic component on base icon component like this. And since base icon component requires one prop name, let's pass this prop in here, and as an icon name, we're gonna reference icon property as before, because now these icon properties contain icon names as strings. So as a reminder, inside of this base icon component, we are referencing property name to extract proper icon component from this object. And this way, base icon component is going to show proper icon. And as a result, our project becomes much easier to support, because anytime we decide to change icon library, the only place where we actually have mentions to that custom library is inside base icon component, where we are importing all those custom components from third-party library. So anytime we will replace that library, we will just have to modify the code of base icon component. And now we see that every icon component is actually represented by base icon component. So in other words, base icon component encapsulates all the logic needed to render icon components. Let's continue in the next lesson. Let's recall what we have done in the previous lessons, and we have created base icon component to represent every icon in our application. So in here we are importing all icon components we are currently using, and down here we also created an object which consists of all available icons. And then we're basically reusing this base icon component whenever we need to display an icon. And the way how we specify which icon to show is actually by passing prop called name. But what we're going to use one icon more than once. In that case, we're gonna have to pass property name with a string value as many times as many icons of that particular type we're using. So in order to avoid repeating those names, we're going to create separate module with all the icons. Let's call this module icons.js. And in here, we're basically going to create constants for every icon name. And then whenever some component needs to use an icon component, we're going to import that icon component as well as the name of an icon represented by a constant. And in case in the future we're going to decide to use different icon library, we will only have to change an icon name in one place, and that is value of a constant which is gonna represent icon name. So let's just cut this import of all icons and paste it in our new module icons.js. And also let's copy that icons object and move it inside of our icons module. And just to follow convention of naming constants, let's use all capital letters and export this object. And now let's start defining constants for every icon name. So I'm going to create in here constants for every icon. And each of these constants should be exported. And every constant name will start with the prefix icon. And now one by one I'm gonna go through all these constants and assign appropriate names that corresponds to every icon. Here the same, we're gonna use capital letters in each constant name, and then we will basically use these constant names as keys. I have actually lost one more icon that should be in here. It is icon plus. Let's add it right here, and then we're basically going to use these constants as keys for icons object. And now we're going to import this icons object in our BaseIcon component. So let's switch over to BaseIcon component and write down an import statement for icons object. Let's not forget and also use proper name in the template. And then we're going to assign validator function to property name. This will be called isIconValid. This validator doesn't exist yet, but soon we're gonna create it. So firstly, let's go ahead and write down an import statement for this function isIconValid. And then inside of validators.js, right after isPageValid function, let's declare an export function with the name isIconValid, which will take one param, which is an icon name we're about to validate. And then this function is going to use our icons object that we have to import from our new icons module. And the way we're going to validate an icon will be as follows. Let's just use keys method and extract all keys from the icons object like this. This expression is going to return array which consists of keys, and then we're basically going to check if past icon is included in this array by using method includes, like so. And this way we will make sure that icon name is valid. So now we're gonna have to go through all the components that currently use BaseIcon component and import appropriate constant names and pass these constants as a prop name to every BaseIcon component. So let's start with nowItem component. So as we can see in here, we're fetching icon name from icon property of nowItem object. So we have to go to that file where these objects are defined, and that is inside constants.js. Here we have array of nowItems where every object has property called icon. For now it stores string icon names, but since we have already defined constants for every icon name, we can just do the following. Let's go ahead and import all icon names that we need in this file. It will be icon clock, icon list bullet, as well as icon chart bar. We're importing all this from icons.js. And now we're basically going to replace every icon name with appropriate constant. So for the first icon we're gonna use icon clock. For the second one, the constant will be icon list bullet. And finally, for the third icon, we're going to use icon chart bar, like so. Next, let's go inside of the header progress component. As we can see in here, we're using one icon called check circle. So we're going to import icon check circle constant and then basically use this constant as a value for the property name for BaseIcon component. Let's just fix a path to import icons module and switch over to the next component. It will be activity item. So this component uses icon called trash. So we have to import icon name from icons module, just like we have done in previous file. And then let's pass this constant to prop name of BaseIcon component. Next file where BaseIcon component is used is baseSelect. So in here we're using xmark icon. Let's go ahead and also import appropriate constant icon xmark from icons module. And in the template, let's use this constant for property name. And now let's continue doing that. Next component is the activity form component. In here, we're also using only one base icon with the name plus. So again, we're gonna import icon plus constant, scroll down to the very end of this file, and use icon plus for property name of base icon component, just like before. And finally, there is one more file where we have to do the same replacement, and that is timeline_stopwatch component. And by the way, in here, we're using 3 icons. So we're gonna have to import 3 constants. Let's do it in here. For this file, we need to import icon arrow pass constant, icon pose, as well as icon play. And then in the template, we're gonna do this replacement for every base icon component. For the first icon, let's use icon arrow pass. For the second one, we're gonna use icon pose. And for the third icon, let's use constant icon play, like this. So now in the browser, if we quickly go through our application, we will see that all icons are still in place. That means we have successfully refactored our icon components. And right now, if we're gonna select one icon component and take a look to the right side of Vue Developer Tools, we can see that every base icon component now imports icons object that we have defined in another module dedicated specifically to icons called icons.js. So now one more time, let's take a look at base icon component. As we can see, the first thing we're doing here is importing icons object from icons module, and then this component also accepts property called name. This is the way how we're specifying which icon to show. And based on this prop, we're extracting appropriate icon component and pass it further to this dynamic component, which is going to render appropriate icon. And inside of icons.js module, we have an import of all icons currently used in our application, and then we have declared constants for every icon, and also used those constants as keys for an icons object. And this is how we are able to use icons object for this dynamic component to properly show particular icon. And the link to the source code of this project will be, as always, in the video description. If we take a closer look at the implementation of our base icon component, we will notice that almost every icon in our application has class called h8. For example, let's consider this icon for the button to delete activity. Let's go to the activity item component. In here we can see where this icon is used. This is this base icon component, and as we can see, it accepts attribute class with the value h8. And the thing is that almost every base icon component accepts this class. So why don't we make it a default to avoid passing this class all the time? So for example, we can go inside base icon component, and in here for this dynamic component, which is going to render particular icon, we're going to pass further property called class that we're about to declare soon. This will be a property which will store all custom classes required for a particular icon. So let's go ahead and declare this property inside define props macro. And here will be an opportunity for us to specify default value for this property. And we're doing this by using key default like this. And in this case, we need value h8. So this property will be a string, and the validator function will be isNotEmptyString. This validator already exists in our project, so we just have to write down an import for this function right here. And also, before we can actually use this function outside of validators.js module, we need to export it first. So let's export this function by making it public this way. There is actually one error that we have to fix before proceeding further, and this error happens inside base icon component. Let's see an error message related to this property class, and most likely this error happens because class word is a reserved word in JavaScript. So let's just rename this property on something else. For example, we can use classes instead of class. And such implementation actually lets us not to pass default class every time we're about to use BaseIcon component. So for example, inside activity item, we have just removed class attribute. And now if we're gonna take a look inside the browser and inspect this icon, we still see that the class h8 was assigned to SVG tag. So because we have earlier specified the default value for the class's property, and therefore this default value was automatically assigned to SVG tag. But if, for example, for certain icons, we will have to assign some custom classes, just like we are doing inside the header.progress component. In here, we're assigning a couple more classes to BaseIcon component. So let's just use our new property classes in order to pass these classes. And then let's go over all the components where BaseIcon is used. And whenever we're passing class attribute with value h8, we don't have to do it anymore. So we're going to remove this attribute. Let's do it inside base select component. Same thing can actually be done inside the activity form component. Here we're also going to remove class attribute. Let's continue doing that. Switch over to the next component. And for example, inside tailwindCss component, we're using 3 icons. So let's just select all these 3 class attributes and get rid of them, like this. And now let's actually test and see how that icon looks like, where we're passing custom attribute classes. So in order to display this icon, I firstly have to change expression inside Vue directive in order for this icon to be displayed. And then we can go to the browser and check if those classes were properly applied. And right away I'm seeing that the icon has become green. That means all those custom classes were assigned to an SVG tag. We can see those classes in here. And if we're gonna select this icon component and inspect it inside Vue Developer Tools, we will actually see that the classes prop is going to store all those specified classes. But if we're going to inspect another icon, for example this delete activity icon, which uses only default class, these prop classes will contain only one default class, h8. And now before finishing this lesson, let's actually test if our validator is not empty string works properly. So to make it fail, I'm gonna have to pass attribute classes with an empty string. Let's do it in here and take a look in our console. Let's make sure that a proper warning will be shown. And the first thing that I'm seeing is that icon styles were changed. And additionally, our validation kicked in and showed this warning. So our validation works properly. We can go back and revert this change. So after this, our console stays clean. We can continue development in the next lesson. Now we'll finally start working on our third page called Progress, and the component responsible for this page called the Progress. So firstly, we're going to put here everything that we'd like here to be displayed, and after we're going to add all necessary logic to make this page interactive. So the goal of this page will be to display all activities that we are currently tracking. That's why I'm gonna add here an unordered list with only one list item, and here I'm going to enter name of the arbitrary activity. So let's just see if this markup is displayed in a browser. Everything is fine, we can continue working on this template. Next we're going to add in here a scale from 0 to 100 that will be showing us our progress for a particular activity. And on the left side we're going to display a percentage that will show us our progress, and on the right side we will see the time that was already tracked for this activity and the time it takes to fully complete this activity. So let's switch over back to the editor. Firstly, I'm going to enter markup for the scale. We're gonna make this scale red, and the width of this scale will be 10% for now. And for the parent container, we're going to make this one flexible container with the height of 5 units. We'll also assign CSS property overflow with value hidden. Let's also round corners of this scale a little bit and make the background light gray. And eventually we're supposed to see such a line. Now down here we're also going to display numeric value in percentage, for example 10%. And on the right side, let's just enter the time we have already spent on this activity and the total time for this activity we should spend in order to complete this activity. And since one of these elements should be positioned to the left and the other one to the right, we're also going to make this wrapper a flexible container, and let's align these elements by using class justifyBetween. The font will be monospaced and the font size small. And right now markup for one list item is almost ready. We just need to add a little spacing, and also we have to add some space in between all these elements. So let's just add class flex to the li element. Let's also make main axis vertical, and the spacing between all child elements will be 1 unit, and paddings from all sides will be 4 units. So now it looks much better, and there is also one more case that we have to cover, and that is when the activity name will be too long, so it will not fit in this container. That means the text will be wrapped on different lines, and in order to prevent this, we're going to assign class called truncate. And let's also make font size a little bit bigger. We'll use XL. And this way, at the end, we're gonna see an ellipsis. This looks good, so let's go back to the editor, remove this big title, and leave only activity 1. Then I'm basically going to copy this whole markup several times, so we will see several items on the page. And now, in between all these items, we're gonna add a little border. So to do so, let's just add class called dividey to this unordered list, like this. And in the browser, we will notice that slightly visible borders appeared between all list items. So let's continue. And now just to make this static content in all these list items different, I'm going to assign different names to every element. First one will be activity 1, second one activity 2, and so on. And the first one will be activity 4. And the same thing now we're going to do with colors. So as we can see, first scale has color red, we'll leave it as is. And for the second scale, we're gonna make color yellow with the class bg yellow 500. The third scale we're gonna make blue. And finally, last scale will be green. So now that we see all scales have different colors, let's just make widths of these scales different. So for the first scale, we'll leave 10%. For the second one, let's make it 50%. For the third one, we'll assign 70%. And for the last one, it will be 100%. And the same thing I'm going to do with the text under this scale. So in here we'll use 50%. For the third scale, let's use 70%. And for the last one, let's use 100%. And basically let's do the same thing and assign different values for the second span, which shows time of this activity. Just to make it differ, I'm basically going to assign different times. And with that, we have pretty much finished markup for this page. In the next lesson, let's split this markup by components. Now that we have finished working on the template for the progress page, it's a time to split this markup by components, so we can simply move markup of individual item into its own component. So we're gonna create new component inside the components folder with the name progress item. But before that, let's just cut this markup of individual list item. On this place, use our new component progress item. And now we're gonna create a new file within components folder with the name progress item. In here, let's create an empty tag template and paste our markup. We're also going to need to write some logic in here. So let's just add tag script with a keyword setup. And in order to use this component in the progress component, we of course have to write an import statement, an import progress item component from the components folder, like so. And also let's not forget to assign keyword setup to this script. So inside the template, in order to show several progress item components, we're going to apply v4 directive and iterate this component several times. For example, let's have an array here, which consists of 4 elements. This way we're gonna have 4 such components on the page. And as a value for the key attribute, we're gonna use an index, as well as we're going to add a prop to this component with the same name index, like so. And before doing anything else, let's switch over to the browser and make sure that all these 4 progress item components appeared in the tree. As you can see, they're all in here, so let's switch back to the editor. And now we're going to make these components look different, and the way we're gonna do so is as follows. Firstly, let's go to progress item component. Here I'm going to declare 3 constants called color, progress, and time progress. And let's just list all those values we were using before in the template and put them in these arrays. So for example, we're using 4 different colors, and let's put all these colors in this array: red, yellow, blue, and green. For progress values, we're using number 10, 50, 70, and 100. And then I'm also going to add all available values for timeline progress array. Let's quickly list all these values in this array. And since we're passing one prop to this component called index, we have to declare this prop by using macro define props and specifying proper name for this prop. So as we can see, we have already passed this prop from outside, and now all we have to do and use it as an index for these arrays. And based on this value, let's extract proper values from each of these arrays and assign 2 corresponding constants like this. And now let's switch to the template section and make some of these values dynamic. For example, activity name we can make dynamic by using the following expression. We're basically going to output different indexes. And then for the color class, let's interpolate constant color like this. And as for the width, we're going to interpolate another constant called progress. And the same constant should be also used in here to print out numeric value of the percentage. And lastly, we also have to use time progress instead of hard coding this string. And what we're gonna do next is actually go back to the progress component, and let's remove all markup from here and leave only usage of progress item component. So now we need to find a way to iterate over activities array. So we can access this array by basically importing it from our global module activities. Let's write down import for this array right here. And now let's just use this array to iterate over it in this before directive. On every iteration, we're going to receive individual activity objects inside this variable activity. And also, we will use here an index of this item. So as for the value for the key attribute, we can use identifier of the activity like this. And then we're going to pass an extra property to this component called activity and pass the whole activity object. And now we can go back to progress item component, declaring here one more prop called activity, and let's use this activity object in order to output the name of this activity right here by referencing property name. And now, as many activities we currently have in our application, as many list items we're gonna have on the timeline page. Currently we have only 3 activities, and which is why we're seeing 3 list items on this page. But in fact, if we switch over to the activities page, we will see that we have assigned the time only for 2 activities, for reading and training, and the coding activity doesn't have any time. So what we have to do instead is actually show only those activities on the progress page which were assigned the time. In other words, we're not supposed to see coding activity in this list. So let's see how we can implement this. Currently we don't have a function to filter out only those activities that were assigned the time. So now we have to create one more function inside activities module that is basically going to do this filtering. So what I'm going to do in here is actually export new constant called tracked activities. And as a value for this constant, we're going to use computed property. Later it will become clear why I have actually chosen to use computed property in here. And for now, let's just figure out what condition we're going to use in this filtering function to filter out only those activities that have time assigned. So if we take a look at the activity objects, we will notice that every activity object has a seconds to complete property, and for those activities that were assigned the time, this property is not 0. So we can use value of this property inside the condition. So here's how we're gonna do this. Let's apply filtering to the reactive activities array. In here, right away, we're going to destructure one property of every activity object called SecondsToComplete, and we'll use this value as the condition inside this closure. So since we are returning the value directly, eventually we're going to receive a new array which consists only of those activities where this SecondsToComplete property is not equal to 0. We can also write all this as a single expression within this closure. We don't need these curly braces. Let's get rid of them. And actually the reason why I have chosen to use in here computed property is because we have to recalculate this tracked activities array anytime activities array will be changing. Because while our application is running, users can actually assign on-remote time from particular activities. So we need to watch this array for changes, and the computed property allows us to do it. And every time it notices that activities array was changed, it is going to run this closure again to recalculate our tracked activities array. So now what we have to do is inside the progress component, instead of iterating over activities array, we're going to use our new computed property tracked activities to iterate over only those activities that actually have the time assigned. And just because in our application we currently have 2 activities that were assigned the time, on the progress page we are seeing only 2 list items. That's exactly what we want. And for example, if I'm gonna reset the time for activity reading, then on the progress page we're left only with 1 list item. And if we'll decide to assign time for every activity, the progress page will also reflect this and display 3 list items. And even if we're going to create new activity, let's say sleeping, without setting up time for this activity, on the progress page we're not gonna see this activity, but right after we're going to assign the time, the progress page will also display our new activity sleeping. So far so good. Let's continue working on this page in the next lesson. So now we're going to make this scale grow as we're tracking the time for a particular activity. And we're gonna make this percentage grow as well. So I'm going to firstly select the time for activity reading. And then on the timeline page, we can start the stopwatch to track the time for this activity. And then on the progress page, the width of this scale should be increasing. And before getting to implementation, let's just do some preparation steps. While generating these activities, I'm going to set up initial time for each of these activities, 15 minutes. So we are generating those activities with the help of generateActivities function. And here I'm going to assign 15 minutes to every activity by simply changing this value assigned to SecondsToComplete property. So we're just multiplying 15 minutes by 60 seconds, and this way we're gonna get value in seconds. And then let's switch over to timeline items module, and inside the function which generate timeline items objects, it is this generate timeline items function, we're going to modify a couple of properties as well. So initially I don't want any of the activities assigned to any timeline item object. So I'm going to basically reset activity IDs as well as activity seconds by assigning appropriate values. And right now, as we can see on the activities page, initially we see that the 15 minutes was assigned to every activity in here. And as for timeline items, we don't actually see that any of the activities were assigned to any timeline item objects. That's what we wanted. So we can start working on the progress. As we know, the component responsible for showing individual progress item called progress item. So let's go inside this component. And right here, we're using static values to specify width of scale as well as showing percentage value under the scale. So we have to make this value dynamic so it will update in real time. And for this, I'm firstly going to comment out this line. And now for tracking the progress, we're going to use computed property. Let's write it down in here. And inside the closure of this computed property, we're going to calculate activity seconds that was already tracked for a particular activity. And thankfully, we already have a function which lets us calculate this value. Let's call getTotalActivitySeconds function in here. And when our stopwatch is running, this closure will actually be called every second. So before proceeding any further, let's firstly import all necessary functions, such as getTotalActivitySeconds from TimelineItems module, as well as function computed from the Vue package. And now let's take a look at the implementation of getTotalActivitySeconds function inside TimelineItems module. As we can see in here, we're referencing reactive array timeline items. And that means that when our stopwatch is running every second, it is going to update ActivitySeconds property of some timeline item object from this array, which is going to trigger the closure of this computed function, so our progress can be tracked at real time. And now we also have to pass one parameter to getTotalActivitySeconds function. This way we're letting this function know which activity we'd like to calculate activity seconds for. And inside this component we can access activity object via props object, like this. And then we're gonna calculate percentage by using the following expression. Let's multiply received activity seconds value by 100, and the result we're going to divide by the value stored inside SecondsToComplete property of activity object. So this way we're calculating the percent of already tracked time. And eventually we're going to return calculated percentage from this computed property. And now in the browser, let's just start tracking time for the activity coding and switch over to the progress page. And this time we're supposed to see that the percentage value will be slowly increasing. And this is happening every second. But of course we don't have time to wait until this scale will be fully filled, cause it will take around 15 minutes. So what I'm gonna do to speed up this process is actually go inside timeline stopwatch component, and here we're gonna create temporary constant, let's call it temp, and store in here value of seconds in 2 minutes, so 120 seconds. And now instead of adding 1 second to activity seconds property every second, we're going to increase this time by 2 minutes by adding our value of constant temp. And the same thing we're going to do in the reset function. In here we're going to multiply seconds by value of constant temp. But of course this is only for testing purposes, later we're gonna remove this constant. And now once again let's start tracking time for the activity coding, and this time on the activities page we will see that the time is decreasing much faster now, so every second it's decreasing by 2 minutes. And of course our scale starts filling in much faster. But when I increase the time for this coding activity, let's say 3 hours, the scale will be growing slower, because now it takes much more time to complete this activity. Next we're gonna fix percentage representation, cause this value needs to be rounded. So let's go back to progress item component, and right here we're gonna wrap this percentage value within function call floor to round the value. Or actually we can apply this floor function to this whole expression and return it right away to avoid creating intermediate variable. We can also refactor this code a little bit by moving this whole logic to calculate this percentage into its own function inside activities module. So right here I'm going to export new function with a name getActivityProgress, which is going to take one parameter, which will be activity object. And in here we can reference activity object directly without using props. And now let's just move the import of getActivitySeconds function from progress item component into this activities module. And instead what we should import inside progress item component is our new function getActivityProgress. Let's write this import. And now instead of using all this logic in this closure, we can simply delegate all the work to our new function getActivityProgress, which is going to calculate percentage value for us. So before going to the browser, let's just fix import path for this function. We should use one dot in here, and just to make the code inside the ActivityProgress function more readable, we can replace this numeric value 100 by the constant. Let's call this constant 100%. And right away we're gonna import this constant from our constants module up here. And then we need to declare this function inside constants module. So I'm going to add a new declaration at the very end of this file for the constant 100%. And the value will be of course 100. And also we can turn the logic inside the getActivityProgress function into a one-liner by removing ActivitySeconds variable and instead using getTotalActivitySeconds function call directly in this expression, like so. And now one final check before actually finishing this lesson. Let's just repeat the same actions and start tracking the time for the coding activity and make sure that on the progress page our scale is properly growing. So everything is working. And one final touch is to actually remove previously commented code inside progress item component. It is this line. Let's remove it. And on that, we are finishing this lesson. Currently in our application we have the bug which is related to colors of scales on the progress page. And let's see what I mean by that. We're going to try to reproduce this bug. So first of all, let's just start tracking time for the coding activity. And as we can see on the progress page, the scale is growing for the coding activity. So this is working. And now let's go back to timeline page and change this activity on reading in here. So as we can see for the reading activity, the scale is growing as well. And finally, let's do the same thing for training activity. And for training activity, for some reason, we can see that there is no scale actually. And this bug is actually related to Tailwind CSS classes that we are assigning to these scale elements. So it's happening because inside progress item component, when we're assigning class to the scale due, we're actually using dynamic expression to construct this class. So as we can see here, we are interpolating value of the color variable. But in order for Tailwind to properly scan all the classes used in our application, it requires so that we're gonna use all the classes as is, and we cannot use dynamic expressions to build up these classes at runtime. So let's just fix this in the following way. I'm going to create a local function in here. So this will be a function specifically dedicated to deciding which class should be used for the color of the scale based on the percentage value. We're gonna have 4 different colors for the scale based on the percentage. So when the current percentage will be less than 33, we're going to use a red color for the scale. If the percentage will be from 33 to 66, let's use the yellow color. And if percentage will be greater than 66 and less than 100, let's use blue color. And finally, if percentage will be over 100, that means that we have finished a particular activity. And in this case, we're gonna use a green color for the scale. And now, as before, just to make the code inside this function more readable, let's just put all these numbers in corresponding constants. So let's create 3 constants, actually 2 constants, low percent and medium percent, because 100% constant already exists. So let's switch over back to constants module. And at the very bottom, right next to 100% constant, let's declare 2 new constants, low percent and medium percent, with corresponding values 33 and 66. And of course, just to be able to use all these constants inside progress item component, we have to import every constant. So let's write an import statement for every constant, low percent, medium percent, and 100%. We're importing all these constants from constants module. And then let's just call this function getProgressColorClass inside this class attribute to dynamically obtain class for this scale. The color of the scale should be updated dynamically based on the current value of the percentage. And let's make sure that this is working as we expect. So let's start tracking time for the coding activity. And on the progress page, we can see that as scale grows, it changes the color. So now, in order to clean up this progress item component a little bit, let's just move the getProgressColorClass into functions module. Before doing that, we're gonna write down an import for this function. And by the way, there is no need to keep this color constant in this file anymore. Let's remove this line and then cut the function getProgressColorClass and move it inside functions module. So let's just export this function from here, and then let's move import of all these constants, low percent, medium percent, and 100% into functions module. So here we're already using one import for constants, so let's combine it into one. Let's also apply the formatting for this file, and once again, let's see how it is going to work. So, since the progress value will be recalculated every second, as we are tracking the time for a particular activity, that function getProgressColor class depends on this value, so it will be called again and assign appropriate class to the scale. And now if we're gonna try to track the time for some activity, in this case let's go a different road and actually create new activity sleeping, and then start tracking time for this activity. And as with all other activities on the progress page, we're seeing that the scale is growing for the sleeping activity, so everything is working fine. We can continue in the next lesson. In this lesson, we're not actually going to be adding any new features to our project, but instead we'll focus on fixing a couple of bugs and doing a little refactoring. And the first bug related to CSS classes, so once I start tracking the time for one activity, then on activities page, if this time will be negative, then this block will be red. But once this time becomes positive, this block should become green. But as we can see currently, it is shown purple. And the reason to that is because we currently applied two different classes that specify text color, text purple 600 and text green 600. So as you can see in here, purple class actually overrides green class. So we have to go back to ActivitySecondsToComplete component. And right here we currently have two computed properties. First one has list of all the classes that are applied to that block that shows the remaining time. And there is also one more computed property called color classes. And this computed property is specifically for deriving color classes depending on the current time difference. So we only have to rely on these color classes, which means we no longer need those classes which specify purple color. So let's remove this class textPurple 600 as well as BGPurple 100. And now let's just quickly test if this works as expected. As always, I'm gonna start tracking time for the coding activity, and on the activities page, let's wait until this block becomes green, once the time becomes positive. And as you can see this time, everything is working fine. So let's continue. The next thing we're going to fix is related to progress item component. This is the component which is responsible for showing the progress scale for a particular activity. So if I'm going to start tracking time for the coding activity, then on the progress page, we're gonna see that the scale is growing. But look what happens if I, for example, change this activity by using this select box. In this case, the scale for this activity starts from 0. But in fact, this scale should continue growing from that point where the previous scale has stopped. And another issue is that after resetting this time, we can see that the percentage shows the wrong number right here. So when we reset the time, this percentage should basically show 0. So let's see why this is happening. And right away, let's open up TimelineStopwatch component. It is the component that renders our stopwatch. And in here, previously we have created additional constant to simplify our testing. It's this temp constant. And in order to make our scale grow faster, every second we are adding 2 minutes to activity seconds property, so that the track time for a particular activity will be growing by 2 minutes every second. But this is only a temporary solution to simplify our testing of progress scales. And also we're multiplying value of seconds by this coefficient temp inside of reset function. But when we change activity by using the select box on timeline items page, this watcher kicks in and it assigns current time of the stopwatch to activity seconds property to the current timeline item. So in this case, we also have to multiply value of seconds by that coefficient temp to keep this time in sync. This looks quite confusing, but actually let's see if it worked. So let's start tracking time for the coding activity and make sure that the progress scale grows for this activity. And then if we go back to timeline page and change this activity, then on the progress page, we will notice that this progress scale didn't start from 0, and also we're going to get proper value of percentage once we reset the time of this stopwatch. So as expected, we got number 0. Next, let's work on the BaseIcon component and try to simplify it a little bit. So currently this component accepts one property called classes, and let's review one example. So inside the header progress component, we have an icon called check circle, And this icon accepts custom classes that we are passing into this component by using classes prop. And of course, that prop gets assigned to the root element of the icon component. But why don't we try to stick to the standard HTML API and use attribute class instead of classes? So let's see if we can make this work. I'm going to specify attribute class, and now moving back to BaseIcon component. And here, in order to actually access values of attributes that were assigned to this component from outside, and additionally, if we haven't declared any props for those attributes or events by using macro define emits, we could access those attributes by using the special object $authors. So if I would like to read the value of the class attribute, I'm gonna have to reference this property via authors object like this. And this lets us not to declare any additional properties inside this component, which means we can remove classes declaration. And right away, validation function is not empty string becomes unused. Let's remove this import, and we can make this function private inside validators module. Let's just stop exporting this function by removing this export keyword. And also, to group private function in one place, let's move this function to the rest of private functions, closer to string validator. So right now, let's go for example inside activity item component. Here we have an icon which uses default classes, so we're not passing any custom classes to BaseIcon component. In this case, this property class will be undefined, which means we're gonna fall back to default class h8. But for the icon which is used inside the header-progress component where we specified custom classes by using class attribute, in this case, these classes will be applied to an icon. And if we inspect both of these icons in the browser, firstly, trash icon, we can see that the default class was applied to this SVG tag, and also if we inspect an icon inside the header-progress component, we also see that this SVG tag has those custom classes that we have previously specified by using class attribute on BaseIcon component. And this way we were able to simplify BaseIcon component a little bit. So let's go next and try to simplify the behavior which scrolls the page to particular timeline item when clicking on these hour labels. And the way we're currently implementing this behavior is by using events that we are firing from the child component to the parent component. Let's jump into timeline item component, and here on timeline hour component we have a listener registered for the click event, and when this event gets fired, we're actually sending scroll to hour event to the timeline component. And of course in here we have a listener registered to listen for this event, and once this event is received, we're executing scroll to hour function that we, by the way, imported from our global module timeline items. And since our handler is currently contained inside of the global module timeline item, there is nothing stopping us to actually import this handler directly inside timeline hour component, so we will no longer need to fire custom events from component to component in order to trigger this function when we click on timeline hour label. So let's just move this listener registration directly on the root element inside the timeline hour component. And since this function also accepts an hour that we have to scroll the page to, we have to pass it as a first param. So let's just go ahead and write an import statement for the scroll to hour function inside timeline hour component. So we need to import this function from one of the global modules called timeline items. And instead inside the timeline component this function is no longer needed, so let's remove this import. Also apply formatting to this file, and we also don't need to register listener for scroll to hour event, since this event is no longer sent to this component. Let's remove this registration. And now let's also remove an event registration inside timeline item component for scroll to hour event. We don't need to use this define emits macro anymore, as well as that is undefined validation function. Let's also remove this import. So now we're handling clicks on our labels directly inside timeline hour component, because we were able to get access to scroll to hour function in this component by simply importing this function from timeline items module. So as we can see, clicks are still working, the page is properly scrolled to a particular timeline item, and when we're gonna click on the logo, the page will be scrolled to current timeline item. And also, if going back to timeline page from another page, the page should also be scrolled to current timeline item. As we can see, this also works. And finally, if we refresh the page, we also have to see that the page will be automatically scrolled to current timeline item. Everything is working fine. We can continue in the next lesson. There is actually one element on the progress page which is not currently updated dynamically in real time, and that is this time shown under this scale. And this number shows how much time we have already tracked for a particular activity. So if we take a look inside the progress item component to see how it is currently implemented, we will see that there is this array which contains static strings, and then we randomly show one of the strings in the template. So we're not going to do this anymore. Let's remove this time progress constant from here, because now we're going to make tracked time be updated dynamically. So let's remove this time progress variable from here, as well as the declaration of this variable inside the script tag. And now let's think what we need to show in here. So we kinda have to show two different times. The first time will be the tracked time for the particular activity, and then the second time will be the total time for the activity that we have to spend in order to complete this activity. And we're going to show both of this time on one line separated by a slash. So first of all, we have to figure out how we can obtain already tracked time for the particular activity, and thankfully we already have a function which calculates it for us. We just need to supply this function with an activity object. And this function is called getTotalActivitySeconds. So let's also specify activity object as the first parameter. And this function is going to basically calculate tracked time for this activity up until now. And as for the second time, it's actually much easier, because in order to get the total time that we need to spend on this activity, we can just read this value from SecondsToComplete property of an activity object. And now let's go ahead and import the function getTotalActivitySeconds from the appropriate module. Let's write down an import statement for getTotalActivitySeconds function from timeline items module. And now let's remind ourselves what this function is actually doing. So, as we can see in here, this function just iterates over all timeline items objects and filters them down to only those timeline item objects that have specific activity assigned, which we're passing as the first parameter into this function. And then it loops over those timeline item objects once again and sums up activity seconds properties, and in the end we got total amount of seconds, and that amount of seconds will be actually the time that we have already tracked for the particular activity until this very moment. So now let's just see what results we will get. Let's start tracking the time for the coding activity, and on the progress page, as we can see, the time under the scale updates dynamically every second. But currently this time is not represented in the format we need it to be, because we have to convert this amount of seconds in the time representation. And by the way, we already have a function which can do this formatting for us. The function is called formatSeconds, and if we supply this function with amount of seconds, then the function will format these seconds in the time format. So we're going to wrap the first expression with this function, as well as SecondsToComplete property, because we need both of these values to be formatted as time. So let's scroll up and import this function from functions module, and once again let's take a look at its implementation. So as you can see, this function receives one parameter, which is amount of seconds that we have to format, and then we just construct appropriate time representation in the form of string. And right away on the timeline page we can see that under the scale we got the time properly formatted. So let's just start tracking the time for the coding activity once again, and now we can see the time is still shown in a proper format and it's updated every second. But currently this number does not match the number shown in this stopwatch. And the reason to that is because inside timeline stopwatch component every second we're adding 1 to total amount of seconds that are displayed on that stopwatch. But since for testing purposes we're currently adding 2 minutes every second, we have to also add that temporary variable to this variable seconds, just to keep all time in sync. And by the way, after doing this change, we actually no longer have to multiply seconds by this coefficient. In this place, let's remove this multiplication. And in one more place where we're actually doing this multiplication, that is inside reset function. We no longer have to do this in here as well. And if we're going to inspect timeline stopwatch component in Vue DevTools, we can see that seconds property will be increasing by 2 minutes, which is by 120 seconds once I start tracking time for a particular activity. And now the time which is currently displayed in our stopwatch will be fully in sync with the time that is displayed under the scale on the progress page. And after I'm going to reset the time of this stopwatch, it will show all zeros, and the same time of course will be displayed on the progress page. Here we also see all zeros. So now let's go back to our editor and do a little cleanup. So inside progress item component, we no longer use property index. Let's remove it from here, as well as inside the progress component, where we're actually passing this property into progress item component. We don't need this index in here anymore. Let's apply formatting. And of course, just to follow one standard of declaring properties, let's just expand this property declaration for activity prop and use an object notation where we specify a couple of additional attributes of this property, such as required. In this case, it will be true. The type of this property will be an object. And let's also specify validation function. Is activity valid? So this function needs to be imported from validator's module. Let's write import statement in here. And let's do one final check in the browser. We'll start tracking the time for the coding activity and make sure that on activities page, the time gets decreasing, and on the progress page, the progress scale gets increasing. And even after I'm going to change activity for this timeline item, the time shown under the progress scale will still be in sync with the stopwatch. Let's also try to reset this stopwatch and make sure that the time shown under the progress scale will be reset to 0 as well. Everything is working fine. And at this point, we're good to finish this lesson. Let's continue in the next one. Let's take a look at our global modules, timeline items, and activities. We'll start with timeline items. And right away, we can notice that here we're importing the data from another global module, activities. And even though this activities array is no longer used in this module, because now the code is commented out, but still we were referencing the data from another global store directly in this global store. And now if we're gonna take a look at another global store, activities, here we can see that we are importing function from another global store, timeline items. So these two global modules are a little bit coupled, because we are directly importing data and functions inside these modules from each other. So what I suggest is to make these two modules, timeline items and activities, completely decoupled from each other. But before that, let's actually rename this function getActivityProgress and assign more meaningful name. For example, we can call this function calculateActivityCompletion%. So let's go ahead and replace the previous function name inside progress item component and use new name calculateActivityCompletion%, and also in this place where we're using this function inside this computed property. And while we're here, let's also rename this computed property on %, and also change all references of this property in our template for the width of the scale, and here for the number shown under this scale. And now let's actually get to decoupling global modules. So in order to decouple activity module from timeline items, we have to get rid of this import of the function getTotalActivitySeconds. First of all, let's see where we're using this function inside this module. It is happening right here inside calculateActivityCompletion%. So let's just cut this function call from here, and we're going to pass this value from outside into this function as a parameter called tracked seconds. So let's also declare this new parameter right here. And now we have to go back to progress item component and find where calculate activity percentage function is used. And now since it takes second parameter, and in here we need to reference activity object by using props object like this. And by doing this refactoring, now we're able to completely remove that import of getTotalActivitySeconds function from activities module, since this function is no longer used in here. So inside progress item component, we already have an import for getTotalActivitySeconds function, but why don't we rename this function on something more meaningful? I'm going to select all occurrences of this function in this file and assign different name. For example, let's call this function calculate tracked activity seconds. As a reminder, this function calculates amount of tracked time by now for a particular activity. And of course, let's also rename this function declaration inside timeline items module. So here I'm going to assign a new name to this function. And now a little bit off topic, but still, let's go inside activities module, find the function calculate activity completion percentage, and right here we're passing activity object as the first parameter, but in fact we're only referencing one property of this object in the body of this function, so let's just apply the structuring to this parameter and extract SecondsToComplete property, like so. Let's continue, and now we have to replace one more occurrence of the function that we have previously renamed on calculate tracked activity seconds. So let's go inside ActivitySecondsToComplete component and let's just replace getTotalActivitySeconds function call on the new name. And of course, same thing should be done with an import statement. Here we're using the new name. And now we can go ahead and remove that import of unused array activities inside timeline items module. And this way we have made these two modules, timeline items and activities, totally decoupled from each other. So there is actually one more thing that I'd like to do in this lesson, and that is related to hasActivity function. So right now this function is used as a condition, but not as a filtering function. So let's just try to create another function which will be responsible for filtering timeline items by a particular activity. This function will be filter timeline items by activity, which is going to take activity object by which we have to filter timeline items array. And now let's find those places where we're applying this filtering, for example inside reset timeline item activities function. So let's cut these two lines and here use our new function filter timeline items by activity and pass in activity object as the first parameter. And what we need to do now is actually paste that filtering logic inside filter timeline items by activity function. And also notice that hasActivity function is only used in one place now, that is inside this function. So there is no need to keep that function around anymore. We can cut this condition and use it directly inside this function filter timeline items by activity. And now hasActivity function can also go away. So we can also reuse our new filtering function in one more place, and that is inside calculate tracked activity seconds. So right here, we're going to replace the first two lines on our new function call, and this way we were able to reduce amount of duplicated code in this module just a little bit. But still, that was a valuable refactoring. So now, let's just take a closer look at the reduce method. So this method is used to find the sum of all activity seconds values of all timeline item objects. And also inside the closure of the reduce function, we're only referencing one property of timeline item object, and that is activity seconds. So why don't we split these two concerns? First of all, we can call method map to go over all timeline item objects and extract only property that we need, and that is activity seconds. And after this, we're gonna get a new array which consists only of values of activity second properties of every timeline item object. And then by applying method reduce, we can actually simplify this closure to make it shorter. So for example, we can rename the first parameter on just total, and the second parameter, instead of accepting timeline object, now we'll accept only value of activity seconds property. So now this closure is going to look like this. Let's just swap these two operands around. And now we have a final version of this function, which in my opinion looks more clear than previous implementation. And by the way, I have forgotten to return the value from filter timeline items by activity function. So in here, we have to add keyword return. And if you wish, we can also apply destructuring to some parameters in this function. So for example, here we can destructure property ID, and in this closure we can destructure property activity ID, and then we'll compare these two variables. In this case, maybe the code has become less readable, but we were able to make it a little bit shorter. And you can actually decide yourself which implementation looks better to you. I'm gonna go with this one. And actually I have missed one more return inside timeline items module. So right here, we also have to return the value from this function, calculate direct activity seconds. And now just to see if we haven't broken anything, let's start tracking time for the coding activity and make sure that on activities page, the time will be decreasing, and on the progress page, the scale will be growing. And even when our stopwatch is running, we still can change activity. And on the progress page, it will affect different scale now. And finally, let's just reset the time of the stopwatch and make sure that all percentages on the progress page will be 0. And as we can see, everything is working as expected. Let's continue development in the next lesson. Let's discuss a little bit how when we start tracking the time for a particular activity, every second we will see that our scale is growing. So how this all happening? For this, we have to open up component which stores that scale, that is progress item component, and right here we have declared one computed property called percentage. And by the way, this computed property gets recalculated every second if we are currently tracking time for some activity. But currently, as we can see, it is not clear which variables this computed property depends on, because for now inside of this property, we're only referencing one reactive variable activity. But in fact, when we are tracking the time for some activity, this activity object is not updated. And what actually gets updated is an object from timeline items array. So how come then this computed property gets reevaluated whenever object from timeline items array is updated? Since we don't see any reference to reactive timeline items array in this computed property. And if we start digging deeper, for example, let's try to open up calculate direct activity seconds function, which is called inside that computed property. And this function calls another function, filter timeline items by activity. So let's take a look at this function. And finally, in the body of this function, we can see a reference to the reactive array timeline items. And that is why how that computed property is able to update every second as any object from timeline items array gets updated, because it is watching this reactive array. So now let's try to make all dependencies of this computed property percentage explicit. And in order to do so, all of them have to be referenced directly inside of this closure. So I'm going to pass reactive timeline items array as the first parameter inside calculate direct activity seconds function. Actually not the reactive array itself, but its underlined value by referencing property value. And now it becomes clear after looking at this function, we can see all reactive variables that this computed property depends on. So now let's go ahead and modify a declaration of calculate direct activity seconds function by adding first parameter, which is timeline items. And now we have to pass forward this parameter timeline items to filter timeline items by activity function, like so. And then let's find implementation of this function and add first parameter in here. And since this parameter is going to contain underlined value of timeline items reactive array, we no longer have to reference this array by using value property. So let's remove this reference and go back to progress item component. And here we have to obtain a reference to timeline items array. We can easily do so by basically importing this array from the global timeline items module right here. And actually due to this refactoring, we actually have to tweak another place in our application where calculate direct activity seconds function is used. So inside ActivitySecondsToComplete component, let's just pass timeline items array as the first parameter inside this function. And just like before, let's add an import statement for this array and import it from timeline items module. And one more time, let's go back to progress item component. There is also another call to calculate direct activity seconds function in this template. So timeline items array has to be passed as a first parameter in here as well. By the way, we can create another computed property which is going to hold value of direct activity seconds. So let's just cut this whole piece, use direct activity seconds computed property, then go up and declare the constant direct activity seconds, which will be of course computed property, and here we'll paste that code we just cut from our template. So we're basically going to return the result of executing calculate direct activity seconds function, and this value will become the value of this computed property. And another reason why we have done this refactoring is because we can actually reuse this computed property right here. So instead of calling this function again, let's reference direct activity seconds property, and to get the underlying value of this computed property, we need to reference property value. So let's move on and actually tweak another place inside timeline items module, and that is this function called filter timeline items by activity, because previously we have added another parameter to this function, and therefore we have to pass this parameter in here, and this should be timeline items array. First of all, we're going to accept timeline items array from outside into reset timeline item activities function, and then forward this array to filter timeline items by activity function like this. And after that, we of course have to find the place where reset timeline item activity function gets called. It is inside activity item component. So let's pass timeline items array as the first parameter into this function. Do not forget to actually import this array from our global store timeline items. So what we are actually able to achieve by doing all this refactoring in this lesson. And now looking at progress item component, specifically at these two computed properties percentage and direct activity seconds, now their dependencies are explicit because we are referencing them directly in these two closures. And now it's actually clear to see that whenever one of those reactive variables will change, this will lead to updates of these two computed properties percentage and direct activity seconds. So we no longer have to dig through function called stack to identify all reactive variables which these two computed properties depend on. So as always, at the end of the lesson, it is important to check if our application still functions properly. So I'm going to start tracking time for the coding activity and check if on the activities page this time will be decreasing, and on the progress page the scale will be increasing. So far everything is working as expected. Let's also select different activity and verify that now different scale is filled in. And finally, let's reset the timeout as stopwatch and make sure that all percentage values on the progress page will be zeros. So far so good, our refactoring was successful, and the link to the repository of this project will be in the video description. Now let's consider one way how we can make progress item component even linearer. If we open up this component, we will see that this component currently has two computed properties percentage and direct activity seconds. And by the way, percentage computed property depends on direct activity seconds, so we can say that these two computed properties are related, and they both kind of represent the same concern. And there is also one more piece of data which is calculated dynamically, which is this function called getProgress color class. And this function, based on the value of the computed property percentage, derives the class which should be used to style progress scale. So right now we're going to consider one way of how we can move these three similar pieces of data in a separate place. And to reuse stateful logic in Vue components, there is a concept of composables. So we're going to create one such composable right now. For this, let's create new folder called composables inside source folder, and let's call our first composable progress. According to the concept, this composable is going to represent, and what composable is a basic function which we're going to export right here. Let's call this composable useProgress, and usage of prefix use in the composable name is one of the conventions how we should name composable functions. So what we're going to insert in this composable is those two computed properties percentage and tracked activity seconds. So let's cut these two properties from here and move them into our new composable. And now whatever data that should be exposed for other components to use from this composable should be explicitly returned from here. And since we need both of these properties accessible in our components, let's just return an object which consists of these two properties, percentage and tracked activity seconds. And as was said before, we also wanted to extract this function called getProgressColorClass from here and move it in our new composable as well. And for that, we're gonna create one more computed property, which we'll call colorClass. And then let's also declare this computed property in our new composable. And this computed property is basically going to determine the class that should be assigned to progress scale based on the change in value of another computed property percentage. And as we know, computed property percentage is going to be updated every second if we have a stopwatch running. Therefore, our colorClass computed property will be reevaluated every second as well. And just to make this computed property accessible from outside of this composable, we also have to add an entry to this object that we are returning from this composable. And now it's time to actually use our new composable inside progress item component. So let's call the function useProgress. And right away, let's destructure return value of this function and use only those variables that we're actually going to need in the template of this component. So this component needs to access color class that should be assigned to progress scale. Also, it needs percentage value, as well as tracked activity seconds property. So we're going to destructure all these properties in here. But actually, in order for this composable to work properly, we have to supply this composable with an activity object that we can access here by using props object like this. And now let's go back to our composable definition, add one parameter called activity, and in the body of this function, we no longer have to reference object props in order to access activity object, because we are already passing activity object directly as a first parameter in this composable. So as it usually goes whenever we use new function in a component, that function should be imported first. So let's write down an import statement for our composable useProgress. We're importing this composable from the composables folder and the file called progress. After this, I'm going to copy all these imports, move them inside progress.js, and here I will basically remove unused imports and keep the rest. And pretty much the same thing I'm going to do inside progress item component. Let's also remove unused imports. And also there is one more thing that I have missed while declaring new computed property color class. And that is this, since we're using another computed property percentage in this computed property, in order to get the value of the computed property, we should reference value property like this. So eventually we end up with such composable which stores 3 computed properties. And by the way, every computed property in here depends on the next one. Color class depends on the percentage, and percentage depends on tracked activity seconds property. And of course, if those dependencies will change, it will lead to updates of dependent computed properties. And by the way, let's just shorten the name of the tracked activity seconds property. Let's call this property just tracked seconds. And after this, we also have to rename references. So inside progress item component, let's rename tracked activity seconds on tracked seconds. And the same thing we're going to do in the template right here. And one more occurrence of tracked activity seconds property exists inside progress.js. At the very end, let's rename this property on tracked seconds. And eventually, if we're gonna take a look at the implementation of progress item component, we will see that this component now looks much leaner than before. And all it does is just imports a couple of functions, then it declares props, and all the complex logic which is responsible for dynamically updating progress scale was moved into a separate composable that we have called useProgress. Actually, this component was already pretty simple before moving all this logic into a separate composable. But still, I just wanted to demonstrate this example of how we can leverage composable functions to move reusable functionality into separate functions. And even if we're not going to use our composable function more than once, it still serves a good purpose of code organization. So now I'm going to check this behavior in the browser and make sure that our application functions properly. So let's start tracking time for the coding activity and make sure that on the progress page, the progress scale will be growing for this activity. And after we're gonna change activity, it will be reflected on another progress scale. And finally, if we're going to reset the time of this stopwatch, then on the progress page, all percentages should turn 0. Great, everything is working as expected. Let's continue development in the next lesson. In this lesson, let's take some time and actually refactor a component called ActivitySecondsToComplete. This component shows activity remaining time. So let's open up this component in the editor and let's see what can be simplified. So currently this component contains quite a few computed properties. In total, there are 5 computed properties. So let's see if we will be able to reduce this amount. So let's start with the first 2 properties, classes and color classes. And they are very similar because each of those store classes for a particular DOM element. So why don't we go ahead and try to combine these 2 computed properties into one. So I'm basically going to return an array from this closure which consists of CSS classes. And whenever I need to determine classes dynamically, I'm basically going to use this expression directly as an element of this array. And now, computed property color classes can go away. And I think that after doing this refactoring, the code actually hasn't become less readable. So let's keep going and get to the rest computed properties. And firstly, I would like to rename this variable secondsDiff, which is used quite a lot in this component. Let's just assign more readable name. For example, let's call this property remaining seconds, because it stores amount of seconds that we still have to spend on the particular activity in order to fully complete it. And now that we have done this, we can also rename component file itself. So currently it is called ActivitySecondsToComplete, but why don't we call it remaining activity seconds? Because this is exactly what this component is used for, to show amount of time we have to spend to finish particular activity. And now let's find a reference where this component is currently being used, and that is inside activity item component, and use the new name, remaining activity seconds. So before actually doing any more refactoring, let's stop here and test this part. So when I start tracking the time for coding activity, then on the activities page, the component that shows remaining time should become green. Once this time will become positive. Let's wait for it. And here we go. Component has become green. So everything is fine. Now we can continue. And now I want to focus on this computed property called seconds. As you can see, this computed property consists of several parts. The first one is the sign, either plus or minus, that should be displayed in front of the remaining time. And then we're calling the function formatSeconds to apply formatting to the seconds stored inside remaining seconds property. But what if we'll try to create another formatting function which is going to format seconds for us? But this function will format the time, including sign. So then we can move this logic which is responsible for determining the sign into that new function. Let's do that. So inside functions.js, right above formatSeconds function, let's export new function which will be called formatSeconds with sign. And just like formatSeconds function, this function is also going to accept one parameter seconds, and then it will basically delegate all the work to the formatSeconds function, and we're going to forward this seconds parameter into this function like this. But the main purpose of this function is to actually determine the sign which should be used in front of the formatted seconds string. So let's just take this whole expression and put it in front of the formatSeconds function call and wrap it all within template string like this. And now we end up with such a len function which sole purpose is to format the time with the sign in front. And this additional function gives us a good opportunity to refactor remaining activity seconds component even further. So we no longer have to specify the sign in front of this expression, because what we're going to do instead is call our new function formatSeconds with sign, which already includes the logic to determine the sign. And now it lets us also completely remove computed property sign. Let's just go ahead and replace import of formatSeconds function on our new function formatSeconds with sign. And I would actually prefer to move this whole expression, which calls formatSeconds with sign function, directly in the template. Because as we know, templates are responsible for presenting the data, and formatSeconds with sign function applies formatting, which is directly related to the template's job. And which is why I'm going to copy this function call and move it directly in the template, like this. And additionally, inside templates, we don't need to manually unwrap array values by referencing value property. So let's remove this property from here. And by moving this formatSeconds with sign function call directly in the template, we have actually applied the same approach that was applied inside progress item component. Here we also left two function calls, formatSeconds, that are responsible for formatting data, and kept them in this template. And finally, since we no longer use computed property seconds, which means this line can also be removed. And at the end, what we end up with is only 2 computed properties versus 5 that we had at the beginning of this lesson. And along the way, we have also created another helper function to format the time, including the sign called formatSeconds with a sign. So I'm going to make sure that this component functions properly. Let's start tracking the time for the coding activity and take a look at this component on activities page. So as time will become greater than 0, this block should become green. That's exactly what we're seeing, which means we have successfully done this refactoring. Let's continue in the next lesson. Alright, right now let's focus on another component, which is this timeline stopwatch component, which represents our stopwatch. And if we go inside the file with this component here, we're gonna see that this component contains quite a bit of logic. So firstly, we declare a local state of the stopwatch by using these variables. And down here, to be able to manage this state, we also declare a couple of functions, which is gonna be responsible for making stopwatch component work, such as start function to start the stopwatch, stop function to stop it, and reset function to reset current time of the stopwatch. So as you can see, this component currently contains a lot of logic, but why don't we just take all this logic and move it in a separate place? So for example, we can create new composable, which is going to be responsible for managing stopwatch state. So I'm going to create new composable inside our composables folder with the name stopwatch.js. And right here, let's just export the function with the name useStopwatch. Here I'm following the convention of naming composable functions and start the name with prefix use. And now let's go ahead, most of the logic from timeline stopwatch component and put it directly into this stopwatch function. So I'm just transferring over registration of the watcher as well as 3 functions start, stop, and reset. And as we can see in the body of this function, we reference variable timeline item a lot of times. So instead of referencing this property on the props object, which by the way we don't have an access to inside this composable, we're going to pass one parameter to this function, which will be timeline item object. And then we can simply remove all mentions of the props object. So next, what I'm going to do is copy all these imports from timeline stopwatch component and paste it into our new file with the composable. And then I'm going to remove all unused imports and keep only those that are used. And of course, the same thing we have to do inside timeline stopwatch component. So let's switch over to this component and remove unused imports here. And there is also one more thing that we still have to move into our stopwatch function, and that is these state variables. So let's cut them from here and paste it into useStopwatch function. Again, we don't have access to the props object, so let's remove this mention and import function ref on top. And now whatever we're gonna need to gain access for inside this composable, we will basically return. So down here, I'm going to return an object from this composable, which is going to contain all the data and functions that we need to reference from outside. So in this case, I'm going to include in here two state variables, such as seconds and isRunning. And in addition to that, we're also going to expose a couple of functions, start, stop, and reset. We absolutely have to do so because all these functions are going to be used inside TimelineStopwatch component. And now I'm basically going to copy this whole thing, then switch over to TimelineStopwatch component, paste it right here, and this will be the structured value from our composable function useStopwatch that we're gonna call right here. And since this function accepts one parameter, which is timeline item, here we can simply pass it through, like so, by referencing timeline item object on the props object. And then let's scroll up and write an import statement for the composable function useStopwatch, and import this function from the composables folder, like this. And as we can see, the ref function is no longer used in this component, so we can remove its import. And then let's scroll down to the place where we are calling our new composable, and this time, as we can see, this component has become much leaner because we have actually extracted all the logic responsible for managing stopwatch state into a separate composable function, and here we're only receiving some state variables and functions that we're gonna use in this component's template to manage stopwatch. And by the way, we can also get rid of this isStartButtonDisabled variable by basically moving the expression which this variable holds directly in the template, like this. And as we know, inside the template, we don't need to reference props object directly in order to access the prop. So let's remove this mention, and then right here, we no longer need this constant isStartButtonDisabled. So I'm gonna remove it. And so what we are end up with in this component is just a couple of imports, then declaration of only one prop timeline item, and usage of our new composable function useStopwatch. So this component is much more simple right now. And now before finishing this lesson, let's finally check everything in a browser. So I'm going to mainly check the behavior of the stopwatch. Let's start tracking the time for a particular activity and make sure this time will be decreasing on the activities page. And on the progress page, the scale is growing as well. So this part is working. Let's also try to stop the stopwatch for a moment, then start it again, and also reset the time of the stopwatch. So as we can see, the behavior of the stopwatch is predictable as before. That means everything is fine and we can continue our development in the next lesson. Let's continue working on our new composable called stopwatch that we have created in the previous lesson. So let's go inside the file with this composable stopwatch.js and look at this composable more closely. And right away we can notice that this composable is currently tightly coupled with timeline item object, because it has a lot of knowledge of this object and it tries to even manipulate it. So in this lesson, let's try to refactor this composable so that it will become isolated, so it will not have any knowledge about timeline item objects. And in order to do so, the first step that we can make is actually accept only amount of seconds in this composable from outside instead of accepting the whole timeline item object. Because at the end, the main goal of this composable is to actually manage stopwatch, but not timeline item object. So instead of passing the whole timeline item object from TimelineStopwatch component, what I'm going to pass instead is the actual amount of seconds that this timeline item object stores inside ActivitySeconds property. And then inside our composable, we can call the new parameter initial seconds, and we're going to initialize our local state with this value like this. So next what we're going to do is actually try to get rid of the rest of mentions of timeline item object in this composable, because currently, as we can see, this composable is trying to manage this timeline item object by calling update timeline item function in several places. So instead what we can do is actually not to try to manipulate timeline item object in here, since this stopwatch composable shouldn't have any knowledge about timeline items, but we can call some kind of a function handle seconds change that we're going to receive as a parameter in this composable, and this function is basically going to be executed anytime the local state of this stopwatch changes. So whenever time changes every second, we're gonna execute handleSecondsChange function and pass in current value of the stopwatch. So now let's declare the second parameter for this composable, which we're going to call handleSecondsChange. And by accepting this parameter, which by the way will be a function, we'll add all components that are going to use our composable. Specify custom logic in the form of the closure that should be executed on every seconds change. And what I mean by that is this. So for example, inside timeline_stopwatch component, we're using this composable. So let's just pass closure as a second parameter into this call. This closure is going to take current time of this stopwatch as a seconds parameter. Because as you remember, inside a stopwatch composable, we are passing current time of the stopwatch as the first parameter into this function. And now all the logic that should be executed anytime value of seconds change, we're gonna place this logic in this closure. So anytime when seconds change, we're going to update ActivitySeconds property of certain timelineItem object by executing update timelineItem function. That's pretty much the same code that we were executing before. We have just moved things around and extracted this piece of code out of the composable and put it directly in this component. And this way we're slowly decoupling our useStopwatch composable from timelineItem objects. And now since we're passing current time of the stopwatch as the first parameter into this function, we can simplify the code in this closure by simply assigning received value of seconds directly to ActivitySeconds property of timelineItem object. And by the way, we need to reference timelineItem object by using props object in this component. Also, we have to import update timelineItem function in this component. So let's cut the import from the stopwatch.js and move it into timeline_stopwatch component. So let's continue our decoupling refactoring. And next, what we're gonna extract out of the composable will be registration of this watcher. So let's cut it from here and move it into timeline_stopwatch component. And of course, timelineItem object should be referenced via props object in both places. Then let's also move an import of the function watch into timeline_stopwatch component. I'm gonna write this import statement right here. Next, going back to our stopwatch composable, and just like we have done in here, where we called handleSecondsChange, we should also call the same function when we reset the time of the stopwatch, and this will be happening inside the reset function. And since in here as the first parameter we are already passing the amount of seconds that we are going to assign to ActivitySeconds property of the timelineItem object, we can just swap these two lines around. So firstly, we're gonna reset the local state of the stopwatch by assigning 0 to the seconds reactive variable, and then we're gonna pass already reset value into handleSecondsChange function. So this value will be assigned to ActivitySeconds property of timelineItem object. So now it's time to check our refactoring in the browser. See if our stopwatch still functions properly. Let's start tracking the time and make sure that time will be decreasing on activities page. And then let's also check if we still can stop this stopwatch. And then reset the time of the stopwatch. And on activities page, we're supposed to see that all remaining time of activities will also be reset. That's what we are seeing. So this behavior is also working. Now let's go back inside the file with the composable function. And as we can see, we can remove update timelineItem import since it's no longer used. And now after looking at our composable representation, we can see that this composable has no knowledge of timelineItem object, and all it does is actually declares internal state of the stopwatch and also declares a couple of functions to manage this internal state. And we have also implemented the way of specifying custom logic that should be executed anytime value of the seconds change inside a stopwatch by simply passing the second parameter into this composable, which will be closure with custom logic. And by the way, if we look at those places where we're executing the handleSecondsChange function inside the composable, we can see that in both places we are passing current value of the local state variable seconds. But the thing is that we are already extracting this local state variable in our timeline stopwatch component, so there is actually no need to pass any parameters into this closure, so we can remove this first parameter and actually reference local seconds variable directly. But since this is a reactive variable, we have to reference value property like so. And technically, after modifying code in this way, we haven't changed any logic. And by the way, let's look at these two function calls, update timeline item here, and also in this watcher. They look identical. So we can extract this logic into a separate function. We can create a local function with the name, for example, update timeline item ActivitySeconds, and paste in here that function call of update timeline item. And now instead of repeating ourselves and calling update timeline item function twice, we can just reference our new function update timeline item ActivitySeconds here as well as inside the watcher. So let's also replace this line with the reference to the new function update timeline item ActivitySeconds like so. And finally, let's go back one more time to our composable function. And here, when we're calling handleSecondsChange function, we don't need to pass any parameters anymore. So let's remove this parameter here, as well as inside the second call. And eventually, let's do final testing. As always, I'm gonna start tracking the time for the activity and make sure the time will be decreasing on activities page. This is working. And then let's just try to stop this stopwatch, change activity in this list. Then let's start this stopwatch again. And on activities page, we are supposed to see that the time for a different activity will be decreasing. So far so good. And after time was reset, on activities page, all components that display remaining activity time should also be reset. So as we can see, it worked. As always, the link to the source code of this project will be in the video description. It is really important to keep our stopwatch logic clean and simple, because currently this component is one of those components that contains the most of the logic. So let's open up this component in our editor and take a look one more time at the implementation of the stopwatch. So we have extracted pretty much all the logic from this component and moved it into a separate composable function, which is responsible for providing stopwatch functionality. And then we're supplying this function with a couple of params, initial amount of seconds that this stopwatch should display, as well as function that should be triggered anytime seconds of this stopwatch will change. But let's just take a closer look how we are calling this function inside of our composable function useStopwatch. And as we can see in here, anytime we modify value of the state variable seconds, right after we are calling that function that we have provided from outside, which is called in here handleSecondsChange. And the same thing is happening inside the reset function. So in here we also firstly modify value of the reactive variable seconds, and only after calling handleSecondsChange function. And since this is the case, there is a good opportunity for us to basically listen for changes in this reactive variable from outside, instead of manually triggering our custom function handleSecondsChange. So for example, what we can do is actually go back to timeline stopwatch component, and in here we are already exposing reactive state variable seconds from our composable function useStopwatch. So now we can set up a watcher to watch for changes in this variable, and then once this variable will be changed, we can trigger any logic that we need. And what we're gonna have to call anytime variable seconds will change is what's inside of this update timeline item ActivitySeconds function. So let's just register a watcher by using function watchEffect from the Vue package. This watchEffect function accepts the closure. And now we're basically going to move all the logic from this function and put it inside of this closure. And the way watchEffect function works is it basically watches for changes in any reactive variable that is currently used inside of this closure. And then it simply re-executes this closure once any reactive variable was changed. And in our particular case, we can see that inside of this closure, we are referencing state variable seconds. So anytime the seconds will change, the watchEffect function is going to re-execute this closure. And now we just have to import this function watch effect instead of importing watch function right here. And then let's scroll down, and we no longer need this watcher. Let's remove this line, as well as the local function update timeline item activity seconds. Let's get rid of this as well. And we can even simplify the logic in here further by basically removing the second parameter that we're currently passing to useStopwatch composable function, because this function is no longer going to use this param, so it only needs to know initial amount of seconds. Let's keep only one parameter. And just like that, we can also go inside of our composable function, remove this declaration of the second parameter, as well as all mentions of this parameter. Firstly, inside this setInterval function, let's remove this call, and then we can simply put all this on one line, like so. And then let's scroll down to reset function. Here let's also remove this function call handle seconds change. And now let's go inside the timeline items module and find the function which generates randomly timeline item objects, which is this generate timeline items function. So I'm temporarily going to uncomment these two lines in order to assign random activities for the first timeline item objects, as well as assign random time for the first 5 timeline item objects. And before going to the browser, we actually have to import activities array from the activities module. So let's write down an import statement first, and then go to the browser and test this out. So let's see what randomly generated timeline objects we got. Let's only focus on those that have reading activity assigned. So as you can see, the second timeline item object has reading activity assigned, and the amount of time assigned to this object is 10 minutes. And there is also one more timeline item object, the fifth one, which has a reading activity assigned, but in this case, randomly generated time is 40 minutes. And now let's try the following. I'm going to start tracking time for the reading activity. Let's just start this stopwatch, and then we're going to remove reading activity on the activities page. And let's see what happened. As we can see, current timeline item doesn't contain selected activity reading anymore, since this activity was removed. And as for the other timeline item objects that also had reading activity assigned, we can see it was removed from those objects, but the time actually persisted. And in fact, anytime we remove a particular activity, this time should be cleared as well. So let's see why it's happening right now. And in order to understand this, firstly, we need to go inside of activity item component, where we have a button to delete activity. And as we can see, we have a listener registered on this button, which calls delete and reset activity anytime we'll delete activity. So inside this function, before actually deleting the activity, we firstly call reset timeline item activities function. Let's see what this function does. And in here, it is basically going through all timeline item objects, filters only those that have activity assigned that we are about to remove, and then it just resets a couple of properties of those timeline item objects, particularly activity ID and activity seconds. But if we're gonna take a look at the template of the timeline stopwatch component, where the time of the stopwatch is displayed, we can see that in here, we're displaying another variable, local variable seconds. But what we actually have to display here instead is the value of the activity seconds property of the timeline item object that was reset after activity was removed. And also let's just reference this property in another place, right here inside disabled attribute. So let's replace this variable seconds with reference to activity seconds property. And now let's test it out one more time. So the second timeline item has the reading activity assigned and the time is 10 in this case. The fifth object has also reading activity assigned, but the time is 40 minutes. And now I'm going to start tracking the time for the reading activity, and then remove this activity on the activities page. Then switch over back to timeline page, and this time the current timeline item activity, as we can see, was reset. And as for other objects, this time, in case of the second timeline item object, besides resetting an activity, the time of the stopwatch was also reset, and the same goes for the fifth object. So in here activity was also reset, and the time was cleared as well. But there is actually one more thing that we have to pay attention to. So one more time, let's go back to timeline items module, And right here, when we are resetting properties of timeline item objects, we're basically resetting the property of all timeline item objects, including the one which corresponds to the current timeline item. And what it's gonna cause is this one. So let's just start tracking time for coding activity. And then if I'm going to remove this activity, then let's take a look what time current timeline item shows. And now we can see that the time was reset, but in fact, we need to keep the time for the current timeline hour after activity gets deleted. So let's see how we can do this. And we're not going to do any difficult implementation. We're just going to use a ternary condition. And we're going to check if the current timeline item object corresponds to the current hour. And the value of the current hour we can get by calling current hour function, which we have defined previously. And if the current timeline item corresponds to the current hour, we're basically not going to do anything, just reassign the same value of ActivitySeconds property to itself. And by doing this, no changes actually will be made to ActivitySeconds property. Otherwise, we will keep resetting this property and set the time to 0, like so. And by the way, custom function current hour was already imported in this file, so we can go back to the browser and do the same thing. So let's just start tracking time for the coding activity and then remove this activity on activities page. And now we are supposed to see that the time of the current hour should actually be persisted. And that's what is happening. We still can see 6 minutes in here. So the time for the current hour was not reset. And as for the other timeline items that had a coding activity assigned, as we can see, the time for all these objects was reset. And now everything is working as expected. So let's go back to the editor. I'm going to revert those changes I have previously made to generate timeline items function by commenting these two values and returning default values null and 0. We needed those values temporarily, only for testing. And now let's scroll up and also remove an import of this unused activities array. And now we are ready to continue development in the next lesson. At the moment, if we're going to remove all activities from the activities page, we're going to see such empty screen with an image and a little description. And the component which is responsible for showing this content is called the activities empty state. And now let's see what is going to happen to progress page in case we will not assign the time to any activity. And as we can see, the progress page in this case is completely empty. So why don't we do the same thing that we have done to activities page and show some content whenever there is no items to display. Firstly, let's go inside the activities component. And the way we're showing that placeholder with an image is this one. We are using Vue directive and checking if activities array is not empty, then we're gonna show activities list. Otherwise, we're showing the activities empty state component. That component with an image and a little description. And now let's switch over to the progress component. And in here we basically can apply the same approach. So I'm going to use VIF directive on this unordered list element, but here we need to check another array, tracked activities, because on the progress page we're only showing activities that were assigned the time. And now I'm going to copy this component from the activities page, move it into the progress page, but in this case this component will be called the progress empty state. So now we also have to move an import for this component. Let's paste it in here and rename this import. We are importing the progress empty state component. And now I'm basically going to open up the activities empty state component, make a copy of this file, and of course we'll call the new file the progress empty state with the same content. And in here we only need to change a couple of things. Firstly, let's change this description text a little bit, then the text in this alt attribute, as well as pass to an image. In this case, an image will be called noTracked activities. Next, inside the folder with all images, right next to noActivities image, I'm going to create the new file with the name noTracked activities, paste in here SVG code of the new image. And now before actually going ahead and checking it in the browser, I have actually made one mistake while importing the progress empty state component. So let's switch over back to the progress component and fix this name, the progress empty state. And now we are ready to check the result. So switch over to the browser. And currently we have time assigned to every activity. So we have 3 progress items on the progress page. But once I'm going to remove the time from every activity, then on the progress page we're going to see our new component that shows an empty state with a new image. And the moment I'm going to assign the time at least to one activity, that component disappears and we instantly see one progress item. So this is working as expected. So now we have 2 different components for 2 different empty states on activities page as well as on the progress page. And before finishing this lesson, let's just do a little enhancements. Let's start from index.html file. We have a div with an ID of app, which doesn't have any content, and in this case, this div can actually be made self-closing, like so. Next, we're gonna do the same thing, but inside base button component. So let's make this slot tag self-closing as well. And now let's refactor these constant classes. I actually prefer using array for this. So let's just turn this whole expression into an array where the first element will hold list of all the classes which need to be assigned to the root element of this component. And as a second element, we're gonna use dynamic class, just like before. But in my opinion, this array notation is a little bit more readable. And one more place where we can make element self-closing is inside the header component. So in here we can turn this div into a self-closing element. And now one more time, let's just check in the browser if we haven't broken anything after doing all these changes. As we can see, all pages are displayed fine, so we can continue development in the next lesson. Currently in our project, we have a way to track the progress of individual activities. So for example, if I'm going to start tracking the time for some activity, then on the progress page, I will be able to see how progress scale is growing for this activity. But what about of total progress of all activities? We should be able to track the total progress of the day as well. And this progress should be displayed at the top right in this header. So the component which shows this label is called the header progress. If we open up this component, we will see that here we have Vue directive that currently has static value true, and that is why we have day complete progress always shown. But now we're going to have to make this behavior dynamic, so that based on some percentage variable, which is going to hold the percentage of completion of all activities at once. And if this percentage will be less than 100, that means we haven't finished this day yet. And instead of showing the complete label, we're gonna show current progress of the day. So let's use this code in here. Otherwise, we're gonna show the complete label, which means that we have completely finished this day. So right next to the percentage value, we also have this div which shows progress indicator. And the color of this progress indicator should be dynamic. So instead of hard-coding red color, we're going to use variable color class. Let's interpolate this variable in here. And basically this behavior is very similar to what we have done inside progress item component, where we were dynamically assigning the color for individual progress scales. And to obtain completion percentage for individual activities, as well as color class, we have used composable function useProgress, and something similar we can implement for total completion percentage. So let's just go back to the header progress component, and right here, instead of showing this hard-coded value of percentage, 20%, we're gonna use dynamic value percentage variable. And now let's copy an example of using this composable function useProgress and paste it into the header progress component. But in this case, we don't need to use tracked seconds variable. Let's remove it from here. And since this behavior of calculating total percentage will be drastically different from the percentage calculation of individual activities, we will use different composable function, and we'll call this function useTotalProgress. We don't need to pass any parameters into this function. Let's remove this param. And now we also have to import one more constant in this file called 100% since this constant is used in the template. And of course, let's add an import for our new composable function useTotalProgress. I'm gonna copy over an import from here, paste it into the header progress file, and change function name as well as pass. The file with this composable will be called TotalProgress. And now let's just make a copy of the progress file and create new file called TotalProgress. Right away I'm going to rename this composable function on useTotalProgress, which is not supposed to accept any params. Let's also scroll down where we return the value from this composable and remove variable tracked seconds. We don't need this in this composable. And now we're slowly getting to the most important functionality, calculation of percentage of total amount of seconds tracked for all activities, as well as calculation of total amount of tracked time. Let's actually comment out this percentage in order not to get any errors in the browser. Switch over to the browser and let's see what we're about to calculate now. So total amount of tracked time for all activities will be the sum of all these numbers, and total amount of time we need to spend for all activities is the sum of these numbers. And then having those two numbers, we will be able to calculate the percentage of the total amount of tracked time for all activities and show this percentage right here. So let's start with calculating the sum of the tracked time for all activities. Now I'm going to create computed property in this composable function called total tracked seconds. And the way we're about to calculate total tracked time is this. We're going to iterate over array of tracked activities, and this array contains only those activities that we have assigned the time for. So then we're gonna call method reduce, and the first parameter of this closure will be total amount of tracked time that we're gonna use to sum up all tracked times of all activities. And the second parameter will be an activity object that we're going to receive into this closure on every loop iteration. And then we're going to calculate tracked time of the particular activity, which we can do by using this function, calculate tracked activity seconds. So let's move this function right here, assign result to the tracked seconds constant, and then we actually have to do one more thing. Let's just use ternary expression in here and check if the tracked seconds will be less than amount of seconds assigned to the current activity, which means we haven't fully finished this activity yet. And in this case, we're going to use value of the tracked seconds. Otherwise, if we have completely finished this activity, we're going to use this value stored in the seconds-to-complete property of the current activity object. And just because we are reassigning value to the tracked seconds variable, let's change this const on let. And now down here, let's just return the following expression, where on every loop iteration we're going to add tracked seconds to total amount of seconds, like so. And eventually, reduce is going to return us total amount of tracked seconds for all activities. But also, in order for this method reduce to work properly, we also have to specify initial value of the total variable. And we do this by using the second param, so the total should start with 0. Now let's scroll up and import this array tracked activities from activities module. And as for this function, calculate activity completion percentage, that calculates percentage only for one activity. But now, since we need to calculate percentage of all activities at once, we're gonna need to use a different function which we're about to create. So let's call this function calculate completion percentage, switch over to activities module, and right next to the function calculate activity completion percentage, we're going to define the new function calculate completion percentage. And the logic of calculating percentage in this function will be pretty similar to the previous function, so let's copy this line and paste it into our new function. But now we need to change some values in here. Because this function calculates percentage of total amount of tracked seconds for all activities, instead of using amount of seconds for a particular activity, we need to use total tracked seconds. But this value we're going to receive from outside. So let's specify first parameter in this function total tracked seconds, and as for the other value, seconds to complete. In the previous function, this variable stored amount of seconds needed to complete particular activity, but now in this case, we have to use total amount of seconds needed to complete all activities. And to calculate this value, we're going to leverage computed property, total activities seconds to complete. And just to make it clear, this variable will store the sum of these numbers. So the sum of all seconds assigned to all activities. I'm going to create a separate computed property to calculate this value. Let's call this property total activity seconds to complete. Then scroll up and start defining this property. And since this property is not going to be used outside of this module, we can keep this private. So let's use computed function and write the following logic in here. And the way we're gonna calculate total activity seconds to complete for all activities is we are firstly going to go over tracked activities array and map property seconds to complete, which stores amount of seconds needed to complete a particular activity. And at the end, we're gonna receive an array which consists of all the seconds that we can simply sum up in order to find out total amount of seconds that we need to spend to finish all activities. We're basically going to use familiar approach by using method reduce to find the sum of this array. And just because this computed property is private property, it makes sense to move it to the bottom where we store all private functions and variables. So let's move it closer to generate activities private function and put it in here. So now it's time to use this function calculate completion percentage outside. In our composable function TotalProgress, we already have an import for this function, so let's scroll down, and in order to calculate the completion percentage, we're going to call this function calculate completion percentage inside this computed property, and as the first parameter in here, we need to pass total amount of tracked seconds for all activities, and this total amount can be obtained by referencing total tracked seconds computed property that we have defined earlier in this lesson. After that, let's just apply auto-formatting for this file and remove this commented property. Now back to the return value and uncomment this percentage variable. So inside the header progress component, we are destructuring this returned value and receiving color class and percentage values. So both of these variables are already referenced in appropriate places of the template. Basically, we are ready to check the result in the browser. So keep an eye on that progress indicator at the top right. I'm going to choose this component in Vue Developer Tools, and let's watch these two variables that we're getting from the composable function, color class and percentage. And once I'm going to start the stopwatch to track the time for coding activity, right away I'm gonna see that the progress indicator changes, percentage is increasing, as well as those two variables change in real time. And of course, individual progress scale is also growing on the progress page. So our percentage, individual percentage for a particular activity, as well as the total percentage, seems to be showing correct values. And just to be sure, let's also try to reset the time of the stopwatch, and after this, the total percentage of the day should show 0. And that's correct, and all percentage numbers on the progress page will turn 0 as well. And just to make sure that this behavior is working fine, I'm going to spend some more time on testing. Firstly, let's go back to timeline items module, and inside that function which generates timeline items objects, I'm going to uncomment these two lines in order to assign random activities for the first 5 timeline item objects, as well as assign random times for those objects. And before going back to the browser, let's scroll up and add an import for used array of activities. So as a result, on the timeline page, we can see that some timeline item objects has random activities assigned, as well as random time. And on the progress page, turns out that all activities have been completed, and that's why the progress indicator of the day shows day complete inside the header. And now just to see that the percentage inside the header will be updating in real time, let's just assign more time for the coding activity, and after that, we can see that the percentage was updated. And now every time we're gonna change this value, the percentage will be recalculated accordingly. And finally, to see this percentage getting increased, let's start tracking the time for the coding activity and make sure this percentage will be growing, as well as the progress scale on the progress page. Everything is working fine. Let's go back to the editor. And for now, I'm going to comment out this import of array of activities, since later we might need this import for testing. And inside the generate timeline items function, let's get back those default values, null and 0 for properties, activity ID and activity seconds. And the reason why we're not removing those comments is because we occasionally refer back to these values for testing. So in this lesson, we have created another composable function useTotalProgress, which helps us calculate percentage of the total amount of tracked time of the total amount of time assigned for all activities in order to complete those activities. Let's continue our development in the next lesson. In the previous lesson, we have created one more composable function, which is responsible for calculating percentage of the total amount of tracked time for all activities, and that percentage is displayed in this component, the header progress. So let's open up this component in our editor. So right here we're calling the composable function useTotalProgress to get percentage value that we are about to display. And now let's go to this function useTotalProgress. And in here, let's take a look at this computed property, total tracked seconds. There is a chance that we can improve readability of this property, because if we take a look more closely at the closure of this reduce method, we will notice that in here we're doing a couple of different things. Firstly, we are calculating tracked time for individual activity, and then we're trying to find the total amount of time tracked for all activities. So why don't we split these two operations into two different steps? So just to make it clear what I mean by that, let's just take a look at the computed property total activity seconds to complete. So right here, as we can see, we're doing a couple of operations, but these operations are kind of split by two individual steps. Firstly, we're mapping over the array, and then we're calling method reduce on the new array to calculate the sum of the elements of this array. So let's try to apply the same approach in our case. The first step will be to call method map, and this method will be responsible for mapping tracked amount of time for individual activities into a separate array. And we are doing this by calling calculate tracked activity seconds function, and then using this ternary expression, and eventually we're going to return the result of this expression from this closure. And potentially it will let us improve readability of the method reduce more. So in here we only have to sum up total with the amount of tracked seconds of each tracked activity, and this way we will be able to find total amount of time tracked for all activities. So this way we haven't changed any logic, everything still works as before. So just to be sure, let's open up the browser and test this quickly. So I'm going to start tracking time for the coding activity, and we will make sure that the percentage and the top right will be increasing. So as you can see, it's working. Let's go back to the editor and take a closer look at this ternary expression. So basically by using ternary expression in here, we're just trying to find the minimum value out of these two, the tracked seconds variable and value of the property seconds to complete. And then we pick the least value and return from this closure. So we can actually rewrite this in a more concise way by calling mathMin on the math object and passing these two values. And then this method is basically going to return us minimum value. So we were able to simplify this a bit, and this way we can even avoid creating this variable tracked seconds by basically inlining this expression in the method min, like so. Let's get rid of this variable, and now that we have only one expression inside this closure of the map method, we can return it directly without using return keyword, and let's also get rid of these curly braces. So one more time, check it out. If we haven't broken anything by doing this refactoring, let's start tracking time for recording activity and make sure that the percentage will be increasing in the header. And as you can see, it does. Now look at the name of this computed property, total tracked seconds. This property stores amount of tracked seconds of all activities. And in general, this composable TotalProgress is responsible for calculating percentage of all activities at once. But if we switch over to the progress composable, and this composable is responsible for calculating percentage for a particular activity. And here we have almost identical property called tracked seconds. But to make it more explicit that this computed property stores seconds of a particular activity, let's just rename this property on tracked activity seconds. And then wherever this property is used, it is used only once inside progress item component. So we also have to rename the reference of this property on tracked activity seconds. Let's continue and work on the progress scale. So let's just see how this progress scale is growing, and every second it is going to update property weights of this progress scale. But once it reaches 100%, it doesn't stop at that point, and the width is growing more. But we don't actually need it to grow over 100%. So let's see how we can avoid this. Inside the progress item component, I'm going to change this syntax on the object notation, where I'm going to specify an object with only one key width, and the value will be different now. We're not going to use simple percentage anymore, but instead we're going to pick the minimum value out of these two, percentage variable and 100% constant. And that means when our percentage will become greater than 100%, we're still going to use 100% for the width of this scale. So let's scroll up and add an import statement for the 100% constant. And now in the browser, if we start tracking the time again, and let's watch how the width of this scale it will be growing. And this time we will see that once width reaches 100%, it will stop here and will not grow more. There is actually no visual difference, but still this improvement is worth doing, since it doesn't take much effort. And the final improvement that I would like to do in this lesson is actually making this scale growing smoothly. And to do so, we just have to apply one Tailwind CSS class to the div which represents the progress scale. I'm going to use array notation to assign these classes, and the class that we need, which is going to animate some CSS property called transition all. And now the difference will be visible. One more time, let's start tracking the time, and on the progress page, let's make sure that this time, this progress scale will be growing smoothly. As we can see, it worked. So that's it for this lesson, and let's continue development in the next one. Let's create a component for an indicator that is going to show us current state of the day. And this indicator will be just a simple line. So since we have to add this component on the timeline page, we need to open up the component responsible for showing timeline page, and that is the timeline component. So let's open up this component in our editor, and right here in the template, we are rendering individual timeline item elements. Right before unordered list, we're going to use our new component that is going to represent timeline indicator. Let's call this component the timeline indicator. As always, we have to create new file for this component. We're going to add this file to our components folder with the same name as component name, the timeline indicator. And right here, let's start with a basic markup for our indicator. We'll represent this indicator by using HR tag. Then we're gonna disable all pointer events on this element by using class pointer events none. Let's also position this element absolutely, increase the index, also stretch it full width of its parent container, assign bottom border of 2 units, and also let's make the color of this border red. So now before opening up a browser, we have to go back to the timeline component and write down an import statement for the timeline indicator component. So let's import this component from components folder, like so. And if we'll take a look at our page, we don't see any noticeable changes, but in fact, in the tree of components, we see our new component, the timeline indicator. And if we'll scroll up the page, there is this red line at the top, which is our indicator. So the next task will be to position this indicator on the page in such a way that it will correspond to the current time of the day, similar to how Google Calendar does it. So let's switch back to the timeline indicator component. Here I'm going to create the script. And the first thing I'm gonna do is import function ref from the Vue package and create constant indicator ref, which I'm going to assign to our root element of this component, this HR tag, like this. So let's think how we're going to determine the correct position for our indicator. Depending on the current time of the day, we're gonna have to shift our indicator down to the appropriate amount of pixels, and this amount of pixels will be calculated next. So let's also assign the style attribute to this HR element, and the only property that we need to modify will be property top, which allows us to specify top offset. We're going to determine this offset value dynamically by using our custom function calculate top offset. So now we're going to define this function. Before coming up with an actual implementation, let's just return hard-coded value 300 and see how it will be reflected on the page. As we can see, our indicator was shifted from the top of the page by 300 pixels. And now we're going to define all necessary functions that are going to take place in our calculations. We'll call the first function calculate seconds since midnight in percentage. So this function is going to calculate amount of seconds passed from the midnight, but in percentage of all amount of seconds in one day. And of course, to calculate the percentage of this value, we have to obtain the value itself. So we'll need another function, which we'll call calculate seconds since midnight. Also, we're going to obtain the height of this whole block, which contains all of our timeline items, including all scrollable area from top of the page to the very bottom. So we're going to get the height of this block by using separate function with the name getTimelineHeight. In this function, we're going to reference our previously created ref indicator ref, which we can use to get a reference to the parent element, which will be container element. We're going to get the height of which. So in here we can use native DOM API, specifically property parent node, which allows us to get a reference to the parent element. And in this case, the parent element of our indicator will be this div. So this is that wrapping div which contains all of our timeline item elements. And we can get all kinds of information about this element by calling getBoundingClientRect method, which also has property that we need, which is height. And this way, we have obtained the height of the wrapping element. And now we're going to write down the formula by which we're going to calculate the top offset to determine how much we have to shift our indicator down. So first of all, we have to obtain amount of seconds since midnight up until this moment in percentage. We can do it by calling our function calculate seconds since midnight in percentage. And then this value we're going to multiply by the height of the whole timeline, which contains all timeline item objects. And then this value we're going to divide by 100. And 100 is represented by one of our constants, which is 100%. And as a reminder, all our constants are currently stored in a separate module called constants.js. As we can see, 100% constant stores value 100. And now let's go next and switch over to defining another function calculate seconds since midnight in percentage. So in here the formula will be as follows. We're going to multiply 100% by seconds passed since midnight up until this moment, and then we will divide this whole value by another constant, seconds in 1 day. And this way we're gonna calculate the percentage of amount of seconds passed from the midnight until this moment. But we don't have this constant seconds in a day defined yet in our constants module, so let's switch over to constants.js module and right here define another constant, seconds in a day. We can represent this value by multiplying hours in a day constant by seconds in 1 hour. And then let's just move seconds in hour constant definition closer to where this constant is actually used, like this. So now that we have defined this constant, let's go back to our dTimeline indicator component and write an import statement, or actually add seconds in a day constant to the existing import statement like this. So moving on and switch over to define and calculate seconds since midnight function. So right here the first thing we're gonna do is get the current date like this. And then by using this date object, we're going to calculate amount of all total seconds that passed since midnight up until current moment. So first of all, we're going to get amount of hours passed since midnight by calling getHours function. And we have to convert this value to the amount of seconds. So that's why we're also multiplying this value by these constants, seconds in a minute and minutes in an hour. And eventually we're gonna get amount of seconds in the amount of hours passed since midnight up until this moment. And then in the same way we're gonna have to calculate amount of seconds in amount of minutes passed since the beginning of current hour. And this amount of minutes we can get by calling getMinutes method. And finally we also have to add amount of seconds passed since the beginning of the current minute. And we can get this amount of seconds by calling getSeconds method, like so. Let's also make all constants uppercased. And let's see what constants we have to actually import before we can use those. First of which is seconds in a minute constant. And another one, minutes in hour constant. Let's add all necessary imports. And finally switch over to the browser to check our result. And right away we are receiving an error in the console saying that cannot access property of the parent node because our indicator ref isn't defined. And that is because by the time when our getTimelineHeight function gets called for the first time, this indicator ref isn't actually defined, because when this function is called for the first time, current component is not fully rendered and displayed on the page. So this DOM element that this ref points to does not exist yet. So in order to avoid this error, we can simply use optional chaining operator like this. And if value property will be null or undefined, the optional chaining operator is going to prevent accessing parent node property on the undefined value. And once current indicator component will be fully rendered, calculate top offset function will be called again. Therefore, indicator ref will point to correct DOM element, and this whole expression will produce correct value, which in this case is the height of the timeline wrapping element. And finally in the browser we can see that the indicator was shifted from the top of the page to this position. And if we take a look at Vue DevTools, we can see that the calculated value of the offset by which our indicator was shifted from the top of the page is around 3000 pixels. But there is actually a little problem because this offset is calculated from the very top of the page. But in fact, we have to shift our indicator starting from the top of timeline wrapping element, which is this div. This is actually very easy to achieve because our timeline indicator is absolutely positioned, and all we have to do is to actually make this element to be absolutely positioned within its parent element instead of within the body element. And the way we will do it is by simply assigning class relative to the wrapping element, like so. This class is going to assign property position with a value relative to the wrapping element. And all absolutely positioned elements within this wrapping element will be positioned relatively to parent container. So my current time is around 15 hours and 30 minutes, which is why we're currently seeing that our indicator is positioned at the top of the hour, which corresponds to the 15th hour. And additionally, it is positioned right in the middle of this timeline item because my current value of minutes is around 30 minutes. So at this point we are finishing this lesson and continue working on the indicator component in the next one, and the link to the source code of this project will be in the video description. Now that we have added component for the timeline indicator, we're going to make this component move down every second as we are progressing throughout the day. So first of all, let's recall how our timeline indicator component is implemented. Let's switch over to the editor inside the timeline indicator component. And right here in the template, we're calling the function calculateTopOfSet in order to determine how much pixels we should shift our indicator down. And this calculateTopOfSet function depends on several values. One of these values is the percentage of the amount of seconds passed since midnight. And this amount of percentage in turn depends on another value, on the actual amount of seconds passed since midnight that we calculate by calling function calculateSecondsSinceMidnight. And so in order to make our indicator position be dependent on the current value of seconds passed since midnight, we're gonna have to set up the timer, which should be executed every second. So let's do it right now. Let's declare a reactive variable called secondsSinceMidnight that is going to store amount of seconds passed since midnight up until this moment. As an initial value, we're gonna use result of the function calculateSecondsSinceMidnight, like so. That means that on the initial page load, we're calculating amount of seconds up until this point and assigning to this reactive variable. And of course, we're gonna have to dynamically calculate percentage of amount of seconds passed since midnight that will depend on the value of this reactive variable that we are referencing right here in this calculation of percentage. And in order to make Vue recalculate this percentage amount, we have to turn this expression into a computed function. So let's create new computed property called secondsSinceMidnight in percentage, and inside the closure of this property, we're gonna place this percentage calculation that depends on the value of secondsSinceMidnight reactive variable. So that means whenever secondsSinceMidnight variable will change, this whole closure will be recalculated, and the computed property secondsSinceMidnight in percentage will receive updated value. And of course, based on this percentage value, our indicator should be dynamically shifted down as we are progressing throughout our day. In other words, we have to make the value of the offset be dependent on secondsSinceMidnight in percentage computed property. That is why we are referencing this property in here. And then let's also turn this TopOfSet value into computed property. So it is going to be recalculated anytime percentage value will be updated. And now we just have to import computed function from the Vue package. Let's do it up at the top. And then let's scroll down and reference this computed property in our template. And by the way, whenever we are referencing computed property from the template, we don't need to explicitly refer to the value property, since Vue will do it for us. And this way we made it so computed property TopOfSet will depend on the other computed property with the name secondsSinceMidnight in percentage. And this computed property in turn, as we can see, depends on a reactive variable called secondsSinceMidnight. And if we're going to change this reactive variable every second, all this computed property will be automatically recalculated. And that's what we're gonna do right now. So let's set up a timer, which is going to be called every second. We can do this by running setInterval function, and in the closure of this function, all we have to do is actually increment the value of seconds since midnight reactive variable, like so. As a second parameter in here, we have to specify an interval, how often that closure that is passed to setInterval function should be executed. We don't actually need to hardcode any value in here. Instead, we're gonna use a constant, and the constant that we need in this case is called milliseconds in second. So that way, we're making the closure of the setInterval be executed every second. Let's just import this constant from the constants module, like this. So now, thanks to this registered timer, value of the reactive variable seconds since midnight will be updated every second, which will lead to update of seconds since midnight in percentage computed property, and this update will lead to the update of another computed property, top of set. But just to make the result more obvious, that we could see how our indicator shifts down slowly, we're going to increment the value of the reactive variable seconds since midnight, not by 1, but by 5 minutes. So we can use the following calculation in here. Amount of minutes, which is 5, multiplied by amount of seconds in 1 minute. So in the browser we get the following result. Right away we're seeing that our indicator moves down, and we also see that all computed properties are recalculated every second. But there is actually another edge case that we have to deal with separately, and that is whenever this indicator will reach end of the page, it is supposed to be moved to the top of the page. But currently it does not happen, so let's emulate this situation. I'm going to modify the current date by assigning 23 hours to current date like this. And on the page we'll see that our indicator will appear closer to the bottom of the page, and after it reaches bottom of the page, indicator actually continues going down. So we have to prevent this from happening, and what we should do instead, when indicator reaches bottom of the page, is to move this indicator back to the top of the page. And one of the ways how we can detect that our indicator has reached bottom of the page is to check value of seconds since midnight reactive variable. As a reminder, this variable stores amount of seconds passed since midnight until this moment. And in case this variable is going to store value more than amount of seconds in 1 day, that will mean that our indicator has reached the bottom of the page. So let's just watch value of the reactive variable seconds since midnight by using watchEffect function from Vue. So the closure passed to the watchEffect function will be reevaluated anytime one of the reactive dependencies used inside of this closure will be changed. And just because our reactive variable seconds since midnight is updated every second, this closure will also run every second. And here we can check if the value of this variable will be greater than amount of seconds in a day. We're basically going to reset the value of this reactive variable by assigning 0 to it, like so. Which will mean that we have actually crossed the point of the midnight and the new day has started. So we have to move our indicator back to the top of the page. So let's just import this function watchEffect from the Vue package and switch over to the browser and check what we get. So once our indicator reaches bottom of the page, right away we can see that it was moved up and it will be moving down again. So this way we have made our indicator change its position dynamically every second. So at the end, let's go back to the editor and remove that modification of the current date. Let's continue working on our project in the next lesson. In the previous lesson we have made our timeline indicator update its position every second. But there is actually a little issue with this behavior related to performance, because once we're gonna leave this timeline page, the timer which is responsible for updating the position of the timeline indicator will not be stopped and will be continue running. Let's just make sure that this is really the case. So I'm going to put console log statement inside the closure of the setInterval function, like this. And let's see what is going to happen whenever we're gonna leave timeline page. So as we can see, logs started appearing in the console, but even after we're gonna leave timeline page, these logs will be continue printing, so the timer doesn't actually stop. So now we have to figure out when we should stop the timer and when we should start it again. And since our timeline indicator component is contained within another page component called the timeline, and in our application all page components are rendered by using dynamic component in the root component in here. And just because we are wrapping this dynamic component in another special component keep alive, whenever we are switching between pages and therefore page components change, they are not actually destroyed, instead their state is cached, and whenever we move back to the previous page, the whole state of the page is restored once we come back to this page. And there is a way for us to know when the page component will be activated or deactivated. And to run a particular logic when the component will be deactivated or activated, we can use a couple of additional hooks that we have already used before. Those hooks are onActivated and onDeactivated. First of all, we have to import those from the Vue package. And now let's start using them. Let's begin with onActivated. So in the closure of this hook, we're gonna place that instruction which starts our timer, which makes indicator update its position every second. And since we're gonna have to stop this timer once we'll leave timeline page, we need to save the reference to this timer in a variable. Let's create the variable in here called timer, and then store the reference to this timer in this variable. And now we can easily stop this timer whenever we're gonna leave timeline page. We will do it inside the closure of the onDeactivated hook. So in here all we have to do is actually stop the timer by calling native function clearInterval, passing the reference to our timer, like this. And now for testing purposes and to make it more obvious when these hooks are actually called, I'm going to place arbitrary console log statements in every hook, in here, as well as inside the onDeactivated hook. So once we're gonna initially load timeline page, we can see that the activated hook gets called, and right after that, our timer starts, which updates indicator position. And of course, once we will go to a different page, onDeactivated hook of timeline indicator component gets called, as we can see, and our timer is stopped, because we no longer see logs of the word timer in the console. And once I'm gonna go back to the timeline page, the timeline indicator component is activated again, and our timer is started as well. But there is actually a little problem with the initial position of the timeline indicator. When we restart the timer, when we come back to the timeline page, we should actually reset the position of timeline indicator. So let's go back to the editor. And every time right before we start the timer to update indicator position, let's update the value of the reactive variable seconds since midnight. We're gonna have to assign the current amount of seconds passed since midnight up until this moment, which means we simply have to call this function, calculate seconds since midnight. And now let's see that indicator initial position will be the same when we initially load timeline page, as well as when we are coming back to timeline page from another page. So looks like the position is fixed now. So at the end, let's go back to the editor and remove all helper console log statements from this hook, onActivated as well as onDeactivated. And this way we were able to improve the performance of our application by starting and stopping the timer which updates timeline indicator position whenever we are switching pages. The link to the repository of this project will be in the video description.